our and now these sessions are going to be recorded. And then at the end of our 2 days, they will be stored. I have to process them and do some edits on them. But then they get stored up to my YouTube channel, and I'll send out links to you so you can go back and review them anytime you need, if you should happen to need to. So just a couple days after class is done, I'll be sending you those, as well as certificates for your continuing education credits. Are either of you a PE or need to have what are called professional development hours for continuing education for any kind of a licensure or any of that?
I do, yes.
Okay.
I'm not a PE, but I do need a continuing education.
Okay. All right. So, well, you both will earn them, so that's no problem. And they'll be nominally 6.5 hours a day. Now, there have been some classes where we've gotten into some things and we'll drift over, half an hour or so late at the end of the day, or 15 minutes one day, 15 the next, so you get an extra half hour. I track all of that. You'll get full credit. It's not just a a stock 13 hours total. Yeah. So anyway, so when all that comes out and you get your certificate, you'll have links to the videos that are recorded. Anyway, all right. So now, so we're recording. We're going with that. I'm going to go to our screen share and bring this up. So I'll share this second screen. Everybody can see that. And come back over here to talk about a couple of things. And then here. Now, part of your materials, there is this PDF document. There's two of them. One's called Carlson Civil Training Guide. And as you can see, there's not really a specific takeoff or construction module training guide, because the basics and the fundamentals of what it is you're doing are all contained in the overall process of civil design. You have to do all these same things to be able to generate surfaces and work with points and all of that. So it does some double duty. That's the official reasoning behind the fact that you're using the civil manual. The real reasoning is that, well, I never really quite got around to making it. So, to be honest about it. But the fact that it really is, mostly the very same thing. So we're going to be taking some guidance out of there, and I'll show you that when we get to it. Now, the other one that's in here is a book called Carlson Takeoff Tutorial PDF. And this is from Carlson, published by Carlson, and it's their user's manual for this Takeoff R9. And it goes to things like, and these are all hot linked. I don't know why they've got red rectangles around them, but I guess just to show you where the buttons are. But now if you see, here's the user's manual, and it goes right into this table of contents, and gives you a little introduction, shows you about registering your software, et cetera. So this is all kind of old crap. You don't really need to worry about it. But then it goes to the file menu, then to the edit menu, then to the view menu. Okay, so if you are familiar with the software, now you don't have to see, here's file, edit, view, and in the R9 version, you've got draw, digitize, raster, elevate, blah, blah, blah. but you have file, edit, view, inquiry, and points in the other version. And then you'll have the takeoff menu. So this book is going through, and it's rather, let's just take a look. Here's a zoom. Oh, this zoom's not good. Let's go to our twist screen surveyor command. So it comes on here. Here's twist screen surveyor. And it shows you any prerequisites, any keyboard command. If you want to type it, that's what it looks like. Restore due north, prompts, twist to 3D view. And you know what this book is basically a compilation of the help system. Each one of these things, if you were to go hit the help button, you'd get this same thing pulled up. All right. And then much later on in the book, and let me see, there are 830 pages. Okay. So much later on, after they exhaust all of the commands, they step you through a little tutorial. Here's your takeoff menu, and it shows you a lot of the stuff that you would be doing. We're still in the command set. And then finally, chapter 20 on page 760, they start in on the tutorials. Okay. And this is, you know, a CAD file takeoff start to finish. You guys may have all seen this. It's certainly something that's a good introduction. There's a lot of problems with this data set. We'll be using it some, and I'll show you. And the reason we're going to use it is because I'm going to show you how to deal with problems, you know, and how to spot them. Because there's you know, one of the Carlson kids, Todd. He's you know, I've known him for a lot of years, and he's a good kid. He heads up this takeoff division for the company, and in terms of sales, and he also does the demos and the training, and he's not even aware of some of these issues. And can he successfully step through a demonstration of what's going on? Sure. Are his answers correct? No, not really, because there's some serious issues with this data that nobody's addressed because he's not looked at them in 3D with the viewer. So but anyway, I want to show you guys that's part of your training, so you have those tools and know how to very quickly evaluate this stuff. Okay, so this again steps you through step by step by step a lot of the different tools, and again we'll go through these as well to prepare these surfaces. Okay, and then this part here, they're going to design a road with a profile, curbs, etc. So those are all things from that chapter 20 on. So there's not, and then they even do a little trenching exercise. Okay, so that part's good. And even though the book itself says takeoff tutorial, you know, 719 pages of that tutorial are just every command explained. All right, but keep that handy, refer to it, you know, when and where you need. Now your civil manual, on the other hand, has, and again we're hot linked on these, you don't see the button, it's the whole line. But you know, there's little things here like actually I need to update that. I'm up to about 40 years now. Let's see, started working actually back in 1982, graduated in 84. So 80, yeah, that's 40 years ago, 82. So anyway, this is not meant to impress you with all of my vast intergalactic knowledge. It's to make sure you have this. Keep that email handy, because once you're done with the class, please don't remain a stranger, because part of your class, you know, part of what you get when you buy the class is access to us as a resource. And so if there's ever any question, any issue, how do I do something? What's this? What's that? What's my best approach? Even if it's something that we do not go over in class, please use that there. You also see in the emails that I've sent you for these class links, it also has my phone number. And that will dial me directly. That's my cell number. It's the only phone I have and use. So it's with me 24/7, although sometimes unable to answer it if I'm in the middle of a rehearsal for choir at church or something along those lines, but I'll always get back to you. So that's the key part there to remember. Now, in this book, there's a couple of things, these little symbols on the side, you can see what they mean. If it's an IntelliCAD only command, an AutoCAD only command, if it's here's a good idea, little light bulb, and here's something that's noteworthy, take a note of it, little notepad. So little things like that, and they're sort of self-explanatory. A little bit about Carlson, and it's basically telling you here in this in general stuff, is it talking about how the fact that at the core of Carlson software, there's still a CAD drawing. Everything is going to be based on that drawing, and it's just a collection of drawn things in that DWG file. There can be lines, polylines, points, circles, text, 3D faces, things like that. But primarily line work, it's going to be polylines, and there'll be some text labeling from time to time, although you don't even really need to have any labeling. If you're not producing finished mapping, if all you're doing is building models, then it doesn't matter whether it looks pretty or not. So the way Carlson works, though, is that instead of requiring you as a user to know the equivalent CAD command to, like if you're going to create a 3D break line or a 3D polyline, which simply means that it's a collection of line segments all hooked together, poly meaning many, line, of course, meaning line. So if you're going to create one of those and you don't know what the elevations are, you would draw, say, a 3D polyline starting at, maybe it's a 0 elevation, or you start with one known elevation, and then you're going to drag it, draw it across some different things that might be at some other elevations, but you don't know what they are exactly until you finish drawing. All right, so you're going to issue, in the CAD term, you're going to say 3D poly. And it says, okay, tell me where you want to start. You click, and it says, what's that elevation? And you don't know, you start with 0, or you do know, you type it in. You go to the next point, and everywhere along the way, it's trying to figure out, where does that go? And you can either snap to the things that you cross and say, read that elevation and apply it to what I'm creating, or in the Carlson way, and this is the heart of what Carlson has done in terms of their software and their commands, is it knows that there's an easier way, instead of having you issue the 3D poly command and then have to stop with every click and do an intersection and read the elevation and jot it down and type it in and do all that. So just go ahead and draw the darn thing, and then we'll write a little command for you that's going to take that elevation, that drawn element, and it's going to walk down the length of that element, and it's going to look for anything it intersects, read the elevation where it intersects that, and apply that elevation to itself so that it creates what you're ultimately after at the end of the day. So in a process that would take a half hour to generate that line work is now literally less than 5 seconds. So that's the whole approach, is that it's going to take the grunt work out of all of this. So it's going to come up and ask you, the user, for some input information, find out what you want to do, find out what you're trying to draw, what layer you might want to put things on. gather up all that information, and then it's going to send that to AutoCAD in the background. Um, so that is what's going to feed those AutoCAD commands, are the answers to those questions that AutoCAD would normally be interrupting you and asking you about. So it gathers it all up at once and sends it back. Anyway, all of that is to be said that in this approach, all Carlson is a series of little helper commands that sits on top of that CAD engine. And at the end of the day, you still have a CAD drawing, the DWG file, and that's what we've produced. Now, we also produce things like terrain models that can load on dozers, and they're TIN files, or triangulated irregular network files, but they were created from this CAD drawing, from the information contained in the CAD drawing, which is the basics, or the foundation rather, of everything that we're trying to do. Okay, so so that's really the heart and soul of Carlson software. Now, the rest of these upfront pages talks about, where you're going to put your work, what, whether you're going to use a what's called a project organization model based on this project folder concept, or a drawing folder concept, which means everything lives where the drawing lives, or a fixed folder, which was the original way Carlson software used to work back in the early 80s, and where everything went into a single subdirectory. That was back when, a 5 megabyte hard drive cost thousands of dollars. So, that's sort of some of this stuff here as well. We're not going to necessarily spend a lot of time on that kind of discussion here, but that's what's in these upfront pages. I just want to point that out to you because it's there, and it discusses it, so you can refer to it if you need. If, however, that is something that you need to that you're finding every day, you run into a situation, ask me. There's no reason we can't divert a little bit from the flow stream here. We're not tied to any particular flow here, but I'm just showing you, there's that, some settings, talks about the menus, general versus modular. Now, again, remember, this is from the civil book, so it's not talking about the R9 stuff, Drew, like you have, but it's talking about a set of pull down menus, and there's general menus, which are draw, well, starting here, file, edit, view, draw, inquiry, settings, and points. Every Carlson software module has those 7 menus from left to right in that order. Whether you're using construction, whether you're using survey, whether you're using GIS, whether you're using hydro, doesn't matter. The mining software, they all have those, and here's what they do. They're called general menus, and it's basically the file menu has some file commands. The edit menu has some edit commands. All right. So draw, well, figure that out. Some draw commands. Inquiry, settings, and points. And points is sort of a fundamental thing to the surveying practice of, that's how we get information about the world into our drawing to start turning it into lines that mean something as we go out and we observe individual locations on the ground. Those will be our points. Okay, and so that's how Carlson software started. They first started as a surveying only program, and over the years evolved, but everything is through there. Now, once you get past this points menu, you start into the modular menus, and they're all different. And civil starts with, for instance, 3D data, surface, SiteNet. There's that little subset of takeoff that's part of civil. Now, you, Josh, are in this construction module, so you're going to start with elevate and surface, takeoff. There's your roads menu. Again, one menu containing civil has, centerline, profile, sections, and roads. You have roads, which has pieces of that. You have a survey menu, which has pieces of the survey commands, the COGO commands, area and layout, annotation, surface and GIS commands. So you can see how this stuff is sort of organized. And there's a trenching module, which is separate from construction. It doesn't really, unless you're a pipeline contractor, it doesn't really add a whole lot to what we're trying to do as a construction company. But if you are a pipeline contractor, then it adds a great deal to it. And that may be something that, you guys look at later on if you do that kind of work. All right, so that's the idea. You go up through the general menus that are all the same, file through points, and then you start picking up these individual menus. And that's all of these first pages are just basically showing you in general what are there. And then we start talking about some settings. We'll talk about a few that we're going to need. So we'll come back to that. And then right in here is where we're going to really start on dealing with our modeling concepts. And we're not going to spend a whole lot of time on points and points groups. This is more for like surveyors. But we will again, all of that stuff is there for you. You can practice those on your own if you'd like. But we do want to get to this bit here. How do we do this? What do they mean? And there's we got a little bit up front, starting on page 18, as a concept, and then 19 through 25, and that's really only half a page there. So 5.5 pages with a lot of pictures taking up a lot of room. That sums up everything there is to know about terrain modeling, he says, with a bit of tongue in cheek. But it's basically what you need to understand. And once you understand those, everything else is just refinement. Okay, so once we'll talk about these, and it gets all of that together. Once you know how to do that, then we're going to be able to apply those tools and that knowledge into the takeoff set of tools, which really try to hide all of this and all of this information and this knowledge. The original takeoff product in the construction module was done to try to hide the need to understand all of that or to think about all of that, and just give you a series of push button responses. I don't particularly think that's a wise approach to this, but that's why it was done. That was the ag tech answer, the way ag tech did their stuff. Hey, you push this button, you click, 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 and there's your numbers. Gee, well, congratulations, ready, go.
If you don't mind,
Sure.
Could you maybe explain briefly kind of the difference between not necessarily the software, but the theology behind ag tech versus like Carlson takeoff? Like I've used ag tech as well, and I'm just curious, why is that $60,000 compared to this? It's doing a similar thing.
Yeah, well, yeah, it's $60,000 because they were successful in getting people to pay that kind of money for it. To me, it's absolute robbery, but they're a legitimate company. They have a legitimate software product, and it's, to some people it's worth $60,000. And I say that, to some people who were to buy the software, it's worth $60,000 if it does what they need to do, and they can take that off their list of things to worry about and move on. Okay. But Carlson, now the modular version, the R9, like what Drew's using, is it's also fairly expensive. It's like 9,000, I think, something high end up there.
Yeah, it's like that.
Yeah, and the IntelliCAD construction module is much cheaper than that. because you're not paying for the AutoCAD part to be built into it. Okay. Because again, it's got that AutoCAD engine, and Carlson has to pay Autodesk for every one of those that they sell. They pay a royalty fee. So, that IntelliCAD stuff, that part is free. That's included free with so you get the entire CAD engine for no cost. And I have no idea what the construction module costs. I'm not into the sales of this stuff, but I know civil is something like $1,750.
So I think ours is like 1,000 a year or something for construction, not bad at all.
Yeah, well, I mean, the whole thing is not, it's not sold on a subscription basis. It's supposed to be, you buy it once and it's fairly low cost, and then you pay a yearly maintenance fee, but that's usually only about 10% of the software cost. So if you're looking at like $1,000 a year,
I think it's 1,000 up front. I was mistaken.
well, that's a pretty good discount, though. I think it might be more than that. But what I was getting at is, if it is $1,000 a year, you might be paying that. Then maybe they've got this price. I don't know if it's like $10,000. That would make it, 10% of that's $1,000 a year. Or do you have more than one license? Or
Yeah, we have a couple.
okay, so all of that goes. Of course, you may have meant that $1,000 a year might be per seat, but if it's what your company pays, then it's spread across those. In any case, the whole point of what I'm trying to say is that it's much less expensive. And to me, the Carlson construction module and even the R9 product, it will actually outperform the AgTech stuff. But AgTech is they're brilliant at marketing. So they were able to successfully market that to get people to pay $60,000 for it, and they get a market penetration. And, it's the same thing to me. Again, I've used CAD systems for decades now. And to me, AutoCAD and even the DWG as a file format, they're pretty much, like something that's been beat into, like driving square pegs into round holes with a sledgehammer. You can eventually get it to go, and there it is. But MicroStation and the DGN file format is much, much more efficient and more stable as a product. But, the world uses AutoCAD because Autodesk managed to get everybody sold on AutoCAD. They gave it to people. They looked the other way when people pirated the software, and everybody used it, and they gave it to colleges, so that when kids came out, they were all insisting on using AutoCAD when they start to work for people. So that part was pretty brilliant from a marketing standpoint. So now they have the vast majority of the world's installations of CAD software, even though it's not necessarily the best. So that's sort of the AgTech approach.
Is AgTech, say, CAD based, or is it different?
Well, it is CAD based. I'm not real familiar with it. I do know it's standalone. It doesn't run on top of a CAD system. So whatever CAD commands, like drawing a line, drawing a circle, doing all of that, they're commands that, their programmers have created. So they sort of mimic the CAD stuff. And even their file that you create is not a DWG file, but I think you can export that out to be either a DXF or a DWG. So, you can ultimately get back to the same output, but it is not strictly, running on top of AutoCAD, unless that's changed in the last year or two, but I really don't think it has. So, again, it's there, but if it were me, and just from a business perspective, a business cost perspective, and if I knew all of these various different capabilities, I would not ever at all consider AgTech, just from a pure sense of how much money you spend, and the fact that you can get even greater capability out of something that's not only does more things, but when you have, say, the construction module that runs on IntelliCAD or AutoCAD, either one, uh, you've got, in addition to that, you've also got a plain old CAD system. I mean, you can use it to draw circuit boards, and you can use it to draw motorcycle engines, so you get quite a bit more capability out of the box. But got to hand it to the ag tech folks, marketing geniuses. Same as Trimble. If you're using Trimble equipment, same deal with them. They managed to succeed, and yet they're very proprietary, and they won't share data. They won't allow you to, they won't work with other manufacturers. They want everything locked down to their own system, and you get surveyors that insist on it and will do nothing else. So, okay, then that's their customer base. So anyway, we can get far afield. I can preach on this for weeks. So, so let's move on a little bit. Let's go to our first bit of business, and let's open up our product. Now, I'm sitting here in R11, and when that starts, Drew, it's going to look like this. You may or may not have this interface. I don't remember when that came about, whether it was R9, R10, or what have you, but
Yeah, R8 starts in a different window, but we actually had a Carlson sent out a 30-day free trial for their R12. So I just downloaded it. So I'm going to be working in that.
okay. All right. So that'll be, yeah, you'll be closer to me in R11 then. Did you attend the webinar they had earlier in the week?
No, I missed it. I had another meeting, unfortunately.
I signed up for it. I knew I wasn't going to be able to make it, but I knew that they'd send out a recording link. So there's a link to the recording. I will send that to you.
Perfect.
To both of you. So let me show you. I have no idea what it is. It's going to be, it's salesman based. It's going to show you what's new and what all they can do. But I'm going to send the seminar link. So R12. I'm putting a note here for myself to send you guys that. And, it's not like, oh, you didn't sign up, they shouldn't be getting that. Carlson doesn't care. They'd rather you get it, because if it gets you to buy R12, then hey, that was the whole point for them putting the seminar in the first place.
Right.
So, anyway, so I'll do that when we're done. So anyway, as this is going to go, I'm going to minimize this, and we'll go, if I can get this to open, to the IntelliCAD based. Now that you see here is Carlson Construction versus Carlson Civil Suite. These are exactly the same thing. It does, all it does is it starts up the CAD system, and then and when you get that started, it's going to go into the module that you were last in anyway. So these are really sort of, it's not two programs, it's just two different loaders. All right, so all right, we'll exit that. Excuse me there while I yawn. All right, so this is going to get started in much the same way. It's going to come up to the startup interface, the start screen. And this one sort of mimics AutoCAD. You can see all these little push pins over here. You can pin those to this. Otherwise, this is just a recently done list. I've got news feeds over here on the right. I've got a set of menu commands over here on the left that I can do, like a new drawing, open up files. This drawings map is kind of cool. It shows you if your drawings are geolocated, if they're all done, say, in state plane coordinates, like if you're a surveying company, you'll actually bring up, it goes out and brings up like a little GIS map the area, and then you can find jobs that might be, close to where you're working. Get you back to Carlson, tech support, academy knowledge base, et cetera, et cetera. You've got this little box down here to skip this the next time if you don't want to use it. I like it just because it keeps my recent files handy. And I've got all this. Now, that being said, here I've got these two buttons that can go from previews or not previews. Different tips over here, tip of the day, and you can cycle through them. Different news, all that good stuff. All right, now, again, this is just an interface, and I've got the start page tab at the top. Got just two menus. I've got this plus button, which is the same as saying I want to add a new drawing. So this becomes, once we're in, let's say if I open this file just by clicking on it once here, it's going to load up, load the CAD system, all the tools and menus and toolbars. And then you can see I've still got this start page tab. There's the file I had open, and when I switch back, it's going to jump down, but I still have these two tabs. Okay, so that's just an interface for me there. I'll go ahead and close that off. So we go back, and now back to this one. The same thing is I've got a little button here to open files, so I can just go out and browse for them, or I've got this little pull right, which everybody forgets. If I just click this button, it steps me through a wizard, or I can sort of bypass some of that and pick a couple of templates. And the templates are just basically, they're DWG files, but they are exactly the same as a DWG file, except when it loads up, it calls itself file1.dwg or file2.dwg. And when you first go to save it, it forces you to give it a name to put somewhere else. So it's much like opening a file that you've already done once before, and then you do a save as, except this keeps you from accidentally saving it without doing a save as. And again, what you would do is you would put a bunch of commands and settings and things that don't normally stick with your CAD setups. You would put in here, like you might pre-build a set of layers with layer names and colors. You might pre-build a set of text styles or line types. Save them in this drawing file, and then use that to get started when you're doing a brand new one. Now, on the construction side of the industry, when that's your job, is going to almost always be working with other people's drawings. Okay, so I mean, and if you're lucky enough to be able to get a DWG file from the designer, well, you're pretty well down the trail past this drawing template setups. However, a lot of civil engineers won't share that stuff. They'll only give you a PDF, and they hide behind the lawyers and say, we can't do that because of liability. And roughly translated, what that means is we're not going to give you the DWG file because we're embarrassed that we don't know what we're doing, and we don't want anybody else to find that out. So once you see our drawing file on the inside, you'll find out that we didn't do as good a job as we could. We produced a paper map that looks good, but we've got some deficiencies. That's what that really means. And I say that from the sense that I am an engineer. I've worked for companies. I know what happens with that. And that there are no reasons whatsoever not to share a DWG. If you are confident in your work and you are sure, and you're going to stand behind what you've done, and you're going to sign your name over that PE stamp, then you should have no problem having somebody else use the digital version of your work. It saves so much time. It saves so many errors in translation and interpretation. But so many of these engineers are so ultra conservative and ultra paranoid that they won't do that. And so we're stuck with PDF work all the time. So in that sense, we're going to typically start an empty drawing and start a new drawing. And we're going to bring PDF drawings inside our drawing so that we can turn that into a DWG file. And there are ways to do that automatically. And there are ways to sort of get a lot of assistance as we go through a semi-automatic manual process.
So
So
are you saying it's not possible to have a DWT template in the construction version?
no, sure. Yeah, DWT templates are fine, and they'll
Okay.
work on both. I'm just saying it's not necessarily of any advantageous stuff if we are getting DWG files from somebody else, because once the DWG file exists, there's no need to have a template to start it up with.
Right. A good part of my job though is we make, say, like false work drawings or random construction drawings that we actually design ourselves. So
Yeah, so
it's really convenient.
Yeah, so DWTs are very handy for you. You're going to use those to sort of get the ball started. Okay. Or to get the ball rolling, to get the game started. And again, what you would set up in there are, let's say you find yourself always creating a whole bunch of layers and assigning colors and line weights and text styles. And you're tired of doing that every time you start a new drawing. Or you find, hey, I had this one drawing that was really good. It did everything I needed, everything, my settings are good. I like it so well. My typical workflow is to open that drawing and then do a save as. Well, if you forget to do a save as and you accidentally hit the save button, you've just, after you've made some changes, then you've just overwritten that earlier file. So if you find yourself in that sense of either A, spending a lot of setup time, or B, always reaching for a previous file and doing a save as, then consider using these drawing templates. You would turn that file into a drawing template, and you do that by simply going out to Windows, it's the file manager, find that file, and then it says .dwg, and you can either make a copy of it or you can just right then and there change it to say DWT, or you can pull down the file menu from inside AutoCAD and say save as a template. When you change it from files of type, you would pull that down and choose drawing template, and it makes it a DWT and it puts it in your support folder. So it's available for you there later on. Okay. But here's what's going to happen. Let's say, let me put this down here a minute. Let's do this. Let's just say, I'm going to make a new drawing. And if I say, new drawing, create an entirely new drawing, next, and then I'm going to say, all right, so I've made a new drawing. I'm going to just exit here, and I want to see what I've got. If I look at my list of layers, I have one layer, and it's a color white, default line weight, the continuous line style. I have one line type, continuous. I have one text style called standard, and it's made with this god awful ugly looking text. Okay. I've got no blocks defined. I've got the only things that I have predefined are like standard dimension styles, materials. It's all empty. External references, I have no attachments. Okay, so that's what I have, nothing there. I would have to go through and create all of those if I wanted to do things on different layers. If, however, I'm back to this start page and I do a new drawing and I use a template drawing, I'm going to choose my Carlson National CAD Standards Civil Survey, or anything that you want, and choose finish. Off it's going to come. And I'm going to, again, just exit this, that sets up some other Carlson stuff, and then look at that comparatively. Now that was a template file that gave me all of these layers. I've got layer 0, that's always there, but I've got C-AFLD, C-AFLD, ASPH, for asphalt. So C annotation, match text, tables, all the C dash. You're going to get down here and you see the different colors. I don't see, here's a couple of different line styles, and you see I've got more than one line style here. So I could have attached any of those into a particular layer. You get down here and you're going to see the C dash layers are going to run into the V. There's, well, first of all, G. So there's G dash anno dash note dash no plot dash pattern dash symbol. And that means general annotation. I've got these copies of which don't really need. They were just there because whoever saved the template file last had accidentally done them. But after the G's, you see I've now got these V dash building, V dash boundary. And V stands for survey, C stands for civil, G for general. And the reason you don't have S for survey is because the structural engineers got to the table first and they got the S designation. So you'll see that, V, and that all of these colors, line styles, weights, layer names are predefined in the National CAD standards, which was an effort at standardizing their CAD work that came out of, I think, the early 90s. But anyway, the architectural community sort of spearheaded that. I was actually on one of the original design groups, committees that were leading that up back in 1993, I believe. But at that point, we didn't ever really get to this level. We were starting to dabble in this stuff and trying to figure it out. And it sort of fizzled. And then apparently, I don't know, the architects or somebody came up with finishing the effort. But in any case, that's why we use a template, is so that all of this stuff is created for me and I don't have to sit here and do it each time. Not only layers, but I've got, look at these line types that I've got as part of my arsenal. There's a ton of them that comes up with that particular one. Text styles, well, I've only really got 2 or 3. Monospace PTXT, which is the point text style, and I would normally change that to be something there. My standard, I would use like Arial, and I use Arial because most of the agencies that I do work with, like the Allegheny County Sanitary Authority, always require that. So I usually just set that as my standard. Monochrome, I've got a monotype, monospace 821. So now I've got different, I've got these defined, and I would save that. I need to save this back as a drawing template later on if that's what I want. Blocks, I don't have any blocks. Dimension styles, no materials, but you can have those as well. All right, now, one of the reasons I like IntelliCAD, and I'm not going to focus a whole lot on this, it's not a CAD class, but if you open another file, let me put this away a second. I'm going to leave this file open, which is just a new file. I'm going to now open up this civil demo. And you can see it has its own set of layers and colors, and these are just one general, the rest are survey, no civil. But I've got things like, here's a block from a point, different text. There's a text style called lot number. Here's maybe different line style. But see what happens here. this civil demo, drawing 2, civil demo. If I look at these given categories, I'm looking at each one of those files. Let's go over here to layers. And let's take a few of these C layers. I'm going to select those. I'm over here in my original. I'm just going to drag and drop them right there on that same category. And now I'll go ahead and close this. And it can be done with anything. Line types. Let's do a few of do some culverts down through some dashes. I might as well get the contours as well. I'll drag those over to line types. Now, close that off. And here's my civil drawing. Here's my drawing up here that originally had all those others, but here's my civil drawing. And now when I look at it by itself, you see the layers, there are those few C layers along with their original V layers. My line types, you see those few extra line types I added, and you can transfer blocks from one into the other, like that SPT9. Now that's just a plus. There's nothing fancy about that block. But I now, in my drawing, which had no blocks in it before, I now have that as a block, and I can just use it in my drawing. Okay, so if I were to insert in the draw menu block from the second choice, you see that's that SPT9, that's the one that is now defined. It's not placed in the drawing, but it's defined in my drawing because I dragged it and dropped it from this interface. Now, this is something that IntelliCAD does all as part of the same command that lets you work with layers. Most people think this is all this little button right here called Layer Manager or Layer Control. They think that's all this does, but it's actually not just layer control. It's, if you see in the title right here, it's under the Explorer, looking at layers. Now the Explorer is looking at layer states. Now the Explorer is looking at line types, text styles, external references. I can choose right here to attach a file, for instance, if you guys are familiar with attaching external references, and even a PDF, like if I just simply say attach, and I look over here at my choices, I've got standard drawing files, MicroStation DGN files, there's my PDF, and I've got image files, point clouds. Okay, so one interface that handles what AutoCAD has you do, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different commands, some of which have their own dialog boxes and everything else. But this is all done in one little command interface. I really, really love it. That's one of the things I love about IntelliCAD. All right, so enough of that. So as we are going to work, we're going to learn now. Josh, I presume you know you're comfortable with layers and properties of objects and all of that, correct?
Yep.
Okay, Drew, how about you? Is that something that's new for you?
Nope, I'm good with that.
Okay, good. So what we're going to now start to talk about here in a little bit is we're actually coming in about 5 minutes away from our morning break. We'll stop here at 10:30. But what we're going to talk about is how does takeoff differ from, say, Carlson Civil or any of the others? Now, in your case, Drew, since you're using the modular version, it doesn't really, hang on a second, I'm trying to get that bit. Well, auto hide. There we go. And dock. Okay, good. All right, so the what we're going to talk about is how this differs from the modular version in preparing surfaces and things like that. If you're using any of the R versions, are sort of insulated from that, but not entirely, because really it's doing the same thing, the exact same thing, but it's just doing it all behind the scenes. So, it's sort of like when Toto pulled the curtain back in the Wizard of Oz. There's a guy back there pulling levers and buttons. So we're going to understand where that comes from and how that approach is different. And it boils down to this. We build surfaces by examining things in our drawing file that have elevation. And we have points, we have lines, and the lines function as barriers or as break lines, and they keep triangle edges of our model from forming across anywhere those lines form. We'll talk about that a little bit after the break. And we have, anything that has the dimension of elevation. It can be points, it can be lines, it can be blocks with, inserted blocks. And Carlson can even read text and derive elevation from read text to use those points. And they're just X, Y, Z locations in space that help define the corners of triangles that, when all stitched together, form a contiguous surface that is our terrain model. Okay. Now, the non-takeoff approach, or the non-3D machine control approach to that kind of terrain modeling, is always that we gather the data from our drawing. We gather objects. Okay, we select things, group them together, whether we want to consider something or not. The takeoff way, and this is that little bit of hiding behind the curtain, is that it's typically always layer membership based. So you basically are going to tell the system which layers contain those things that you want to use to create your model. Doesn't have to be that way. It can also be done the other way, but most users never are even aware that it can be done the other way. Then they're happy to just go through their whole process of saying, hey, if it's on this layer, it's existing. If it's on that layer, it's design. Everything else is other. I've got existing versus design. What more do I need? Bing, bang, boom, off they go to the races. And that's okay. But I want you guys to have a much deeper understanding of what's going on behind the scenes, and you can figure out, how to really fine tune your work and refine what's going on with it. Okay. So with that, it's coming up on 10:30 here. We're going to take about a 10-minute break. So I'll actually give you about 11 minutes now. So what I'm going to do is I'll go ahead and pop this off, and I will pause the recording. Oh, sorry about that. I turned the recording back on. I was sitting there chatting away. I noticed I had muted myself I had just gotten a call and I wanted to play the voicemail, which turned out to be nothing but telemarketing anyway. All right, so what I'd like you to do is go ahead and load up your software and get into an empty drawing. It doesn't matter what it is, where it is, any of that kind of stuff. Here, I just started a new drawing, and from a template that we talked about a minute or so ago. And, but we want to go over a couple of settings that we need to look at. Okay. So, when you get that new drawing up, and it doesn't matter, you're going to have different toolbars, very likely. I've got my properties palette up and permanently docked over here on the left-hand side. I've got these tool palettes over here on the right-hand side that can fly out, and I can, do different commands over that. I'm not sure. What version are you using, Josh? What year version? Look up in the upper left corner on the top stripe of the software. It'll tell you.
2021.
2021. Okay. I think this was available in 2021, the tool palettes. If you just start typing tool and then choose tool palettes, if you want to see those, and I'm not suggesting you do that. I don't really use these, but I keep these here to point out that it is like, here's a lot of the file commands. There's a lot of edit, view, draw, inquiry, settings, and points. Well, notice what that happens to be.
Yeah.
Okay. So if that is helpful to you, that's where you can get that. There's also in the options, which if you look under the settings menu, IntelliCAD settings, let me see. IntelliCAD options right here on the settings menu up here near the top. And that brings up, the typical, what AutoCAD calls options. And somewhere in here is a setting to turn that palette on and off, I think. But if you just start typing tool, you'll get that. And the command.
If I've got them on tabs at the top, I feel like I don't need them anywhere else.
Correct as well. Now, you also may have, like, are you using this ribbon interface?
I usually close that so I have more screen room.
Exactly what I do as well. So, and that's why. Now, and I've got a few of these out now. Keep in mind, what I have out here is usually what I do in a workflow that's more civil based than takeoff or construction based. And I just know where things are pretty quickly and can jump back and forth to them. I also keep this one here, which is my snap toolbar. I put it out here just to show people, if they're not familiar with it and where it is, they can put it there and get to it. I'm always of the habit that I'll hold the shift key and right click the mouse, and that brings this up. I can pick it from here as well as coming up here to pick it. I can go down at the bottom where my entity snap settings are, and right click that and choose the settings where I can turn on the ones I want to have permanently on.
Yeah, I'm familiar with all this.
Yeah. Okay. So that's that bit. We won't dwell on any of that, but let's look at the settings menu, and I'm going to talk about a couple of things that we do need to talk about. And we'll go first, the settings menu to Carlson configure. Now, everything in here is going to be a different category. We've got something we want to pay a little bit of attention to, and it's generally things that you're going to set and then leave alone. And of course, you can save this collection of settings and reload it. You can do that at pretty much any dialog box in the software. So if you're stationing a center line, it has a save and load, because you're basically saving all the answers to all the dialog box questions that you can reuse later on without having to constantly go back and change them to different things. You might have different client needs, different stuff like that. But in any case, don't lose sight of these save and load buttons at the bottom. is one thing, but a couple things we want to talk about first. Let's go first to the general settings. Now, this is going to control how the product works every time you start things up and start into working on your files. The first one, use the startup wizard. If you uncheck that, then when you start this up, it's not going to step you through the wizard. I like to have it on because it forces me to go ahead and name the file and put it in a specific place. If I don't have that, I get lazy and I just start flying around working on a file. And then, you know, I had to constantly pull down selector menus to switch to different directories. So that sort of gets me to get everything set up the way I want it to do it out of the gate. If we uncheck that here, or as you're doing the wizard, there's a box that says skip this next time. You can turn it off there. This is where you turn that back on. All right, and a couple of things to be aware of. This ignores 0 elevations. Now, you two are both working in areas that are sufficiently inland. You're not working down on the coast where you could conceivably have things that have elevation, but it's numerically 0 because you're at sea level. But what this means is when you go to select items, either by you picking them or by the fact that they live on a certain layer, if it has a 0 elevation, then it's just ignored. So you don't have to freeze them or put them off in somewhere else or take them out of your selection set. You can go ahead and select them and they'll just ignore them. It's a really handy way of doing it so you're not constantly screwing around with layers. All right, the next one to look at, if you're looking at mine and going to model it, do not use this use software rendering. Uncheck that if you're using a Windows-based machine, because that will take advantage of your video card and it will use your 3D chip-based rendering. I have mine on because I'm actually running this on a Windows emulator. I'm running on a Macintosh. You may have noticed from this over here. See, I'm in a, you know, I'm running a Mac. So, but I'm running a program called Parallels that lets me load up Windows and then run Windows software. That's why I have that one on. Now, let's see, a couple of things. I typically work with annotative scaling. Are you familiar with that? It's not going to have a lot of effect for us because we're working with data more than map making. But normally when we're producing drawings, I like to take advantage of annotation scaling. I'm going to turn it off for right now just because it slows things down when it goes to generate points. Like I can draw locate points. If I have that on, even drawing like 150 points into my drawing will take 10 to 15 seconds. Whereas if it's off and it's not trying to set things up and assign annotation scales to each of those blocks, I can draw 1,000 points in about 2 seconds. So that'll speed that up for you. The other things to notice up here, you're not going to be so concerned with points unless you do a lot of survey work and bring points in. This is just a coordinate file format. The default is fine, alphanumeric. This one allows you to collect GIS data along with those points. So it's more survey oriented. Now this part down here, object linking, is sort of important. When we have linking on, now all of these settings, they don't, like if I have linking on, I do a bunch of work with it, and then I come back in here and if I turn this off, for instance, the things that I already created with the linking on still behave as if they're linked on. It's only for, you know, from this point forward. Now I'm not going to link line work with points. And that has an effect. I'll explain these real quickly. linking points with the coordinate file. If I change a point's location in the drawing, even if I just use a CAD move command and I move it, it's going to notice that and it's going to update my external coordinate file with that new position. Now, this used to be sort of dangerous because it worked either with linking on or off, and it did so silently. It never told you. It either did it or it didn't do it. Now, regardless of what that's set to, when you move something, it tells you that, hey, you're in a different location than what the CRD file says. Do you want to update the CRD file, yes or no? So that's what that one is there for. Linking line work with points does, when you draw polylines, whether they're, or even lines, regardless of whether it's 2D or 3D, and if it is done by stipulating a point, like if you draw to a point number, as you may notice when you're drawing, if you're drawing a feature using the Carlson draw tools, it will say pick a point or point number. So you can click, 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 pick in your drawing, or you can type numbers and ranges of numbers. You could type, click, 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 and then you might have points 1 through 20. And you could say, click, 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 and then you can say 5-8, and it would jump to point number 5 to 6 to 7 to 8. And then you can go back to clicking, or you can type then say 15-11, and it would go 15 to 14 to 13 to 12 to 11 and carry on. So if you've done that, and if you've created any of that line work based on going to a point, a Carlson point, if linking is on, if that point gets moved, the line will go with it. Now, if you grip edit the polyline and move the polyline, it won't pull a point with it. But if you go back and edit the point that it originally was used to create it, at that point, as soon as you hit save from that edit, it will go back and redraw the line and go back to that point location again. So that's what that one's for. Labels with line work. If I use any of the annotation commands that put like distance or distance and bearing or curve information, anything like that on any of the line work, if I then grip edit those lines or do anything that changes the orientation of that line work, it will recompute, erase the old labels and redraw the labels based on where those lines have moved to. Line work with center lines. Again, that's working with roadway alignments. And by the way, let me ask, do either of you guys do any kind of road construction, like formalized highway work?
Yes, we do.
That's entirely what our company does.
Okay. So you're going to probably need to be familiar with center lines and profiles and such like that. So if you have a center line drawn out in the drawing and that's turned, the linking is on. If you, well, I'll show you a real quick demonstration of that here in just a minute. You see how it works. If it's on, if you change the line work in the drawing, it will go out to that CL file, centerline file, and it will update the centerline file. Likewise, if you edit the centerline file by going in and typing in the length of a tangent or the radius of a curve or anything like that, it will change its shape. And then when you say save and exit, it comes back out and redraws that line work. And if you've linked labels, if you have stationed that center line, it will recompute and redisplay all of those changes. Okay, so whether that's on for you or not, I'm gonna go ahead and group my point entities. Point entities are, there's three things that make up a Carlson point. There is an AutoCAD point or a CAD point, which is just a node. And then there is possibly optionally a graphic block, and that's the symbol that you use for that point, whether it's a triangle, a circle, a plus, or an X, something like that, or a tree, or an inlet grate, anything. And then there's another block that is a block of three attributes, which are the point number, the elevation, and the description. And if you say group point entities, then if you go to move that, you can select it and it grabs everything together and works on that as a group. If you don't, you can move those things around individually and sort of get them out of sync. And then finally, maintaining the coordinate file history. Again, if you're not dealing with a lot of Carlson points, it's not going to be all that important. But if you do, if you have a lot of survey point data and anybody makes any changes to the coordinate file, and then you say, oh crap, I shouldn't have done that, but now I've screwed up my points. Well, you can roll through those changes and roll it back to where before that was done. So it doesn't, it lets you reset everything that's done to those coordinates without having to do an undo in the CAD system where you might have drawn some things in between. It doesn't affect those. It only changes those CAD or the point coordinate values that you may have changed. Now, this next bit, remove arcs. We have two choices. Which method that you choose to use is up to you. Whether you want to use a maximum offset or a chord length methodology, and then based on those, you give it values here as to how it's going to do that. Now, removing arcs, you may wonder, by the way, just to skip down here to conclude this, unless you're using a digitizing tablet, just turn that on to use mouse. Otherwise it will, and when you do that, it's not going to try to turn on a digitizing tablet when you're working, when you do anything that has a digitize command in it. I presume neither one of you guys are using digitizers.
No, we're not. I'm not, sorry.
Yeah, they're it's not used all that often anymore because now it's pretty quick and easy to do heads up digitizing on the screen. It used to be our preferred method of getting paper drawings into our CAD work. We'd tape them down to a digitizing tablet and start to use them. So we don't do that much anymore, but it's still there. The software still supports it. But anyway, back up to this concept here as to removing an arc. Now you can leave your stuff set there like that if you want. I'm just going to demonstrate it here real quickly. I'm going to say okay and exit, and I'm going to show you what I mean by that. If I have a 2D arc, let's just draw an arc. I'll give you 3 points. I'm going to go here and here and here. Now I've got a line that's drawn as a 3D arc. Let me change that. I'm just going to put down a different layer here with a different, man. All right, so here's an arc that's 2D, and you can, let's see, let's presume that, you know, we are representing, say, a curb return. In fact, let me shape that more like what a curb return would look like. All right, so when we're out there and we need to model this into our surface. Now that curb, that edge of asphalt on this curb return is right now it's it's a single arc and it has a single elevation. It can only have, and it can be, it can have a numeric elevation. I can give it, an elevation for it up here, and it makes the entire arc at that elevation. So that's an arc. Or even if I turn that even into a polyline, I'm going to come down here and go edit polyline utilities, edit our entities to polylines. I'll make that into a polyline. And wow. This thing is set to, all right, now it's back. All right, so what that means is this. Right now, as a polyline, it has, over here you can see a constant elevation, right? It happens to be 0, it could be 100, it doesn't matter what it is. but it's constant elevation. Now, if I'm trying to model that into my terrain, this is in real life not going to be necessarily at the same elevation. It might start here at, say, an elevation of, 98.62, and it comes up here into the parking lot and it hits up here at, 101.35. So it climbs, goes up through a vertical change. Well, if I were to try to do that with an arc, say from here up to here, now that this is a true arc, it can have, I go to my inquiry drawing inspector. Let me see. Drawing inspector on and off. What's it's not. Yeah, that's what I was trying to do. All right, so I'm going to display curve data, for instance. So if I look at that and hover the mouse, I see that it has a given radius, 9,033. It's got a length, 14,000. It's a huge arc. It has a chord distance and a delta angle. So, but if I were to take this as an arc and it had this starting elevation, it had a different elevation. So if I, nail this down on this end and go over here on this end and pick it up in the air so that it climbs upward, or maybe even goes down to a point and then climbs up. When I do that, this is no longer an arc, because if I pull this straight up, say 10 feet, it still looks like an arc when I'm looking straight down on it. But if I look at it perpendicular to the shape that this is now in, to that new plane, this is 10 feet higher. If I then, tilt my head to the left and look at it at that new perpendicular direction, the shape of this is no longer part of the circle. It has been stretched out. So that's why we can't, and no CAD system in the world can create a true three-dimensional arc. And it has to do it. The way we get around that is that we create a series of little line segments, and I'm just going to put 2 of them in here for now. Okay, so now we could well, let's do this. Turn this. Wow. Turn my drawing inspector off. All right, so my right mouse menu wasn't working exactly. So if I say want to add a vertex, and let's just go to here. All right, so let's look at it in this case. So what we do to approximate this in 3 dimensions is we sample that starting at the beginning elevation. We put down a series of connected little line segments, okay? And when we do that, we're going to, the computer is going to do that for us, but it's going to decide based on that number. And we had, 2 numbers, one of which was this, this distance. All right, see, it's huge. 233.9. Or we can have this distance in that case. 4,000, but you can imagine if this was of normal size. Let me change these colors here. All right, so these are our two options. We can do, this one is the option of maximum offset. This is the option of chord length. Now, your goal is to try to turn this into a three-dimensional element with a bunch of these little segments, but you don't want so many segments that you wind up with a bazillion points along this thing, because every point in this resulting replacement is going to be the corner of a triangle. Okay, so if you have, 10 million points along that line, because this is so tiny, you're going to have 10 million little triangle points in there, which we're going to form at least 10 million triangles, plus any others that it can see away from it on either side. So you don't want to make it so tight that you get too many, but you don't want to make it so far away. In the case of, if we only say had 2, then we go to try to build that with our machine control. We're not going to build it out to here. It's going to build it right to here. All right. So you want enough to where you approximate it, but you don't do a lot of overkill. So that's what this value means right here. If you use a maximum offset, I'm saying replace that arc with a series of 3D segments such that the maximum offset from the arc is 2/100ths of a foot. So that's close enough to where it's really going to follow the curve nicely, but it won't necessarily be too many. Now, alternately, you could say, well, always use a chord length, but always make those a certain length, 1 foot, or in this case, a 1/4 foot, or whatever you want it to be. Okay, so I like this method, maximum offset, in the sense that if I come back out here again, and at this curve, if I'm using that maximum offset, such that it generates this type of thing. I'm saying, 2/100ths, that's close enough. And that's, but say this is a certain length. If that were the length that I said, then it's always going to use that length, even if, say, if my arc were really severe, then that length is going to slide over here, slide over here, slide over here. So it's always going to be that length. But in that case, my offset's going to be greater than if my curve were flatter. So keeping that offset being the same is going to, in my way of thinking about it, going to give me the optimum mix. And there's no right answer to that. There's no rule of thumb. It's just, through experience, you're going to figure out how many that you're going to generate. All right, so that's what that part does. Now, again, our linking and how we're going to remove the arcs, that's probably what you want to sort of focus on there to make sure those are done. All right, now that's on our general. These other type of things like drawing setup, that's just sort of some starting values. I'm not going to really go through a bunch of that. Startup settings, when the product starts, here's a default template to use, which you can change it to your own company ones. Where is it going to start looking for projects if you use a project folder method? Profile name, you generally leave that alone. That's the CAD profile that controls the settings of menus and toolbars and such. All right, so what we're going to be looking at that we want to control is going to be found down here in our takeoff/SiteNet settings. Now it says takeoff / SiteNet because SiteNet was that little subsystem that's included in the civil menus. Okay, so, and I may actually, no, it looks like I'm in the takeoff module, but so there's a lot of the same commands under SiteNet, and it's going to be, and it's going to work according to what we do with these settings here. So go ahead and choose that. And let's take a look about what it will do. Now, this upper block called surface modeling, these settings, this is going to be what happens when it goes to build a surface based on certain things that we collect. And again, the takeoff process, the takeoff workflow reads things on certain layers and uses them to create a surface. And we also have to put a boundary perimeter around it for it to work to begin with. And so when we say yes or no to extrapolate a surface out to the boundary perimeter, if we don't have any data out there near the perimeter, if that's unchecked, then it's going to stop the surface generation when it runs out of data. Now, we may have a perimeter that's bigger than our data because we're doing 2 surfaces typically at any given time. We have an existing and we have a design. And so if we want, say, our design only, does basically the center parts and leaves the edges undefined, but we want to find out what happens, and we can say, well, go ahead and extrapolate our design surface all the way out to that boundary. Or if you don't, it stops it where the design data stops. So if it is extrapolated, then when we go to compute volumes and things that are out there, maybe beyond the edge of our design, it's going to incorporate part of that extrapolated surface, comparing it to the existing surface. And if we do have this, if we have it unchecked, this goes away. If we say we will extrapolate it, then we're going to say, all right, I want you to use the existing surface to go ahead and extend my design surface out to the edges. Now, what happens with this is that it's going to go out to the end of our design data. And hopefully, typically, we would be, the end of our design data is a tie-in point or a toe of slope where we be, or top, where we have tied our design down to the existing ground. And if that's the case, this is what we want to do, because once it hits the existing ground, then it's going to just follow the existing ground out to the full perimeter, the full boundary. If we don't do this, and if we don't, if we do have this on, use the existing surface to extrapolate the design, but we do our design where we go, say, hit the edge of a parking lot, and that's the only thing we define. We haven't told it to take that edge of the parking lot and slope it down to the existing ground. If we haven't provided that data, then it's going to go out there, hit that edge of parking lot and drop it vertically down to the ground and then follow the existing ground. So this may or may not be what you want to do, depending on how you build your design surfaces. I always like to tie my design into the existing ground. So I would typically go ahead and have that on at that point. If it is unchecked, then what it does is it goes to the end of our design data, and it then looks at the boundary around what might be the existing surface, might go out to that boundary, and it just does a straight line fit between the edge of our design, even if it's on the existing ground, and runs out to the edge, and it overlooks anything in between where our data ends and the boundary. So you have a ditch going through there on the existing ground, it's not going to incorporate it. That's why I like to put this on here as well. However, if we don't tie our design surface into the existing ground, we just ended up there in the air, if we uncheck this, then it won't drop down vertically and walk out to the boundary. It goes from the edge of our design and straight lines it to the boundary. So it's a little, it's a different set of, you can imagine where you'd have a triangular wedge of earthwork required as opposed to going to the edge, dropping it straight down and running out. So, it sort of is a flag based on how you do your design. Hopefully you're going to get in the habit of tying your design into the existing ground and then let that follow the existing ground out to the boundary. Using the binary triangulation file format, probably, it's faster, it's smaller. Otherwise, it puts things in text readable file form. No real need to not do that. It can minimize flat triangles for an existing surface. Now that's pretty important. And you'll see how that has an effect here in a little bit, because a lot of times when we build an existing surface, the only information we have are existing contours. Sometimes that's all we get out of a PDF, or maybe the engineers did give us a drawing file, a DWG file, but the only thing they had in it were the drawn contours. If we don't have minimized flat triangles on, then those contours could force flat triangles to form up in the peaks of those contours, where it sees the other side of itself as the contour turns back and heads back down the hill. It looks across and it sees that and it says, oh, okay, it's the same elevation from where I'm sitting now to the other side of the contour, and that forms a flat triangle. What happens is, let's say we have a bunch of V-shaped contours that walk down a curb line. And if we haven't done a couple of things, we'll go through some exercises here in a minute. If we haven't created a break line down the noses of those contours that will force those triangles to come down to that line all the way down along its feature, if we're just letting it go contour to contour point, then you're going to jump across those. And when you take a profile down that line, it's going to look like a set of stair steps. It's going to be a flat triangle. It'll drop down, go a little bit, and then go flat again, then drop down and go a little bit and go flat again. So it looks like, a set of stair steps. If we have it on that says minimize flat triangles, then it's going to look at that mathematically and try to keep the number of flat triangles to a minimum if it can. It's not perfect, but it's helpful. So that's why we want to turn this on, to get rid of those potential errors. Same thing would happen for our design surface, because sometimes when we're designing our design surface, again, sometimes all we have are the contours, and you run into that same issue there to where you want to minimize those flats. And then I'm going to turn on my densify break lines, and I'm going to put that in, I'll say to 10 feet. Now, why I'm doing this is, let's say I have, I'm going to go ahead and exit this. You can leave yours on. But if I have a, if I've got a situation like, let's say I had a parking lot edge and it went from, say, here up to here. And then I had a, a curve or something came around. But let's say this is, a couple hundred feet long. I've got an elevation here, I've got an elevation here, and those are the only 2 points I've got in this feature. Well, when I go to model this as a surface, and let's say over here, I've got another, now these would be 3D, I'm just doing 2Ds at this point. But I had something over here that was a feature like this, then, it's got all of these triangles. or all of these points, and it would be a, you know, a triangle conform between the points of any of these features. So I would get a triangle from here over to here, a triangle edge. I would get a triangle edge from here up to here, from here up to here, from here over to here, from here, you know, all the way around until I get to where this one now starts to take over. It does from here to here, from here to here, here to here. So I wind up with this giant triangle because nothing connects in those little intermediate triangles up to parts along this line. I can, however, let's see. Let me turn this into a 3D. We'll start here at say 100. And we'll take that to 105. And do the same thing here. We'll go from say 101 to 104. All right. So now the 3D. So again, there you can see the triangles would be, you know, 100 to, or 101 to 100, whatever these are individually. And same thing from here. This one was 104. This one is 105. This one is 104.035. This one is 103.659. So those would form those triangles only from here all the way up to here, but really to make a smoother surface in here, instead of having this giant set of reaching triangles in here, I need to have, you know, triangles that are more evenly distributed across here. So what I can do with that is if I densify, let me get an idea of what the distance is here to show this. $800 feet. All right. So I could manually, let's see, densify this, and let's say I did that every 500 feet. All right. So now it has placed vertices in this line, even though it's straight from here to here at a constant slope. And I don't need these to define it in my CAD system. Now, when the triangles are going to form, I'll get triangles, you know, that are more evenly distributed here. It makes a smoother and more representative surface. Okay, that's the way we used to have to do this. With the option to densify the polylines, however, and I will now reduce these, and I'm back to just the two. If I say densify the polylines when I'm building my surfaces, it's going to, in memory, put in all of those vertices that it needs to be able to create triangles here, but it doesn't add it to this part of my CAD file, keeping my CAD file smaller and a little more manageable, because if I click on this and I've got all these vertices here, I can accidentally snap to the endpoints and all of that. Plus, it just adds more data into the drawing file.
Does that do that automatically on arcs, or is that something we have to, that's
Well,
based on the chord length and stuff?
Yeah, well, remember the arcs is going to do that replacement based on those chord lengths, so it won't need to. However, if in the case of we had, remember that arc and we had, let's say we just had the 2 points, you know, basically from the start
Right.
to the center to, then it would still densify that replacement. It would go ahead and put those, you know, the 2 points in that looks like, you know, went from here to here to here.
Right.
It would still do that, but then it would come through and densify all along here by that interval. Okay, so if this were, you know, let's say we had our arc replacement such that, you know, it was a little more, you know, representative. I would probably need that. So we had it, so we modeled it pretty closely and we had 1, 2, 3, 4, 5, 6, 7, 8 vertices here. And then when it said densify polylines, it looks at that and sees, well, if this is bigger than that number, which I put in at 10 feet, then it would go to 10 feet and put an extra vertex there. But if it's closer than that, it doesn't need to, so it doesn't add one. Okay, so yeah, it does do that, but again, it only does it in memory when it's building the surface, and then it throws them away, doesn't need them again until it tries to do it from memory again. Okay. So that's what that does. I like to turn it on so it's always there. I don't have to worry about it. And again, depending if you're working on a 5,000 acre, industrial site and you don't need to see them all that closely, you might up that value, or you might just uncheck that and let it go. Right now, the draw triangulation surfaces is whether you want to draw 3D faces or you want to draw a surface object. Now this is not really fully implemented yet. They are in the process over at Carlson of defining a terrain object to become a CAD type entity, like a polyline, a circle, and then you're going to find a terrain object. It's much the way things like Civil 3D work, where it's actually part of the DWG file, but it does it through extended entity data. I'm not a big fan of that. I still like to have my data in those regards stored externally. So in case anything ever happens to the DWG file, I'm not stuck with losing that information. But anyway, that's just a matter of when you go to draw the triangulation surfaces, how you want to do that as a default choice. So it really has not a great deal of effect at this point, because really when we draw the surface, we're going to be drawing sometimes contours or whatever else, which is done through a different approach. It's whether I want to draw the triangles or not, and I generally don't. It just hogs up my drawing, and I can always see those when I go to my surface viewer. All right, so now.
Do these settings save? So every time you open Carlson, it's set up like this, or is this something you configure each time?
No, this is saved.
Okay.
Okay, good question. Now, when I build these surfaces, and again, I've got existing and design, that's my concept under takeoff or under construction. I've got these two conditions. I can say I don't want to reduce, let's say I've got a whole ton of information for my existing surface, and I want to say I want to reduce that surface down a little bit, make it a little less cumbersome to work with. I could say, well, reduce existing, but don't reduce design. And this offset distance is, that's, if it looks at every triangle corner in the model, and it says, if it is within this number of being the same elevation as the other triangle points around it, then it is a candidate to be removed. So it takes that point out of the model and fills back in. Let's say I've got a center point here, and I've got 15 triangles around the edges of it. But if that's the same height within that value of these other points, then throw it away. And then it rebuilds the triangles. You might take 15 triangles down to 3, in which case we've reduced it, but you've lost that little nuance of that point. And so I'm going to keep my surface reduction set to none. The reason I'm doing that is because computers are such now that even very large surfaces don't take all that long to calculate and review. So, you can look at that and decide. Now, these surface file suffixes, this gets to the heart of how it produces material reports and shows different depths and different surfaces. Because when you say build existing and build design, it's going to what these programmers called the original ground, there's a misspelling there. It's going to build actually 3 surfaces, and it's going to do the same thing for design, because we're going to typically have the existing ground, that's the before adjustments, so that stands for original ground. Now these can be anything you want, but the defaults are pretty self-explanatory. So there's my original ground, and that's my top of my existing surface, you know, the top of the ground. If I have defined zones in my throughout my site that says, all right, I'm going to come down here and define, I'm going to do, you know, I've got subgrades to where, you know, I'm going to, let me see if I'm subgrade zones. This is for topsoil stripping here. Zones of topsoil stripping. So that's going to be my EX. But my subgrades are where, like, I define areas where I have to excavate more because I've got bad material, for instance. So I'm going to actually go down and remove more than I would have to if it were just standard soil, and I could build back on top of wherever I take it down to, based on my wherever my design goes. So any of those adjustments, it's going to build another surface and put this as a suffix on that surface name, and it's just going to call it the names that it uses by default are the same as your drawing file name, and it puts you know, whatever the drawing file name is without the .dwg, and puts a -og and then a .tin. So it makes that surface, it makes that surface, that one. Same thing over here for design. I've got my base, that's my before adjustment. Here's my subzone, my subgrade zones, and that's for when I define, let's say, a building footprint, or maybe a parking lot has, you know, 4 inches of asphalt and 8 inches of stone and another 12 inches of well-graded aggregate and dirt, you know, as a sub base under all of that. So it builds that, because really when I'm grading to wherever that parking lot is going to be, I'm not going to grade just to the surface, the top of my asphalt. I have to grade down to the bottom of where those other materials are going to go into. So that's what that surface is going to be. And this after zones and topsoil, that's my final. So that's going to be my final after I've put back like topsoil replacement. So that's going to include now, again, I'm not going to grade to the top of my topsoil. I'm going to grade to the bottom of my topsoil and then put 6 inches or a foot or however much topsoil is on top of that graded surface. And that, when I get up to the top, see, and that becomes my base surface where I grade to the bottom of where I'm going to put that in. And then this is my top overall top finish surface, includes the top of the topsoil, the top of any of these subgrades. So that's my ultimate final surface. So FN for final, BS for base, DS to take care of any subgrades underneath that, and then my final after all of these replacements. And then if I have any over excavation surfaces, and that's not often used, but it's there as an option. Now, this business down here is really, really helpful on these colors. And you may have noticed when I said okay and came out of this, that the colors of those things I had drawn, they all changed to white all of a sudden. I don't know if you noticed that when you saw me go out of it to show something else. But what that does is, and this does not work in SiteNet, the civil mini portion. It's only in this where you have the full takeoff, even though this is also in the settings under civil, it has no effect. But what this does is, if I say automatically update the colors, so anytime you make any changes to anything, it's going to look at it and it's going to decide, is that entity defined as being an existing entity or a design entity, or everything else being other? And if it is one of those things, it's going to make it either whatever color, and you can choose by hitting that button. I'm going to say existings are green, designs are blue, and others are this light gray. And that's if I choose this assigned by target. Okay. If I don't say assigned by target, then only this is going to apply. But assigned by target means it's going to be these colors if and only if, when this is checked, it has an elevation. So if it doesn't have an elevation, it is red. Once I give it an elevation, it will change to either of these colors. Okay, now the elevation for others doesn't ever apply because other is never considered. All right. So what happens, and the way this is helpful, is when I'm looking at my map, let's say I've brought in a PDF file and I've got a bunch of drawn contours all over the place, but they're not at their right elevation. They're just flat zero. So I need to go through and start elevating those contours to tell it what elevations they are. And if they have zero elevation, they're going to be red. So I go through and I'll change one, or I'll change a series of, 10 of them together. And then I'll look around. And if I've got a big site, I can tell the ones that I haven't changed yet because they're all red. So I don't have to keep looking at it in 3D and figuring out or selecting it and reading its properties to see if it's been elevated or not. It just lets me know visually at a glance based on those colors. So this part is really helpful. And this is something that you're going to want to come back in. Let's say you've done all of your elevating and you're tired of everything being green and blue and you want to see them, their original colors based on their layers. Then you would uncheck, you would uncheck this one and maybe you can leave that one on, but it will update from this red back to by layer. But if you have this on, it's always this. So these are things that happen to our entities. And essentially what is going on from a CAD perspective is it's selecting everything that says it's existing. And if it has an elevation, and it's selecting it and it's going over to properties, and instead of leaving its color to be the typical choice of by layer, it changes that to specifically being green. If we uncheck that and go back, then we would select those entities again, or just select everything and say, put the color back to by layer. And that would change back to those original colors. You'll see that as we're working, okay? But that's a really good way to help us know that we've elevated something successfully or not. Okay, so we'll say okay to that, and we'll say exit, and that's really all we need to start getting started with some of this stuff. Now, I told you I was going to explain this one since you guys do, or Drew anyway, does some roadway work. One of the options under general was this link line work with center line. And what happens is this. I'm going to do a zoom center. I'm going to go to 5,000, 5,000. In zoom center, I just typed ZC. So I'm at 5,000, 5,000. Now it wants to know a height. Now it's not an elevation in the air height. That's the height of the screen from bottom to top. I'm just say 500. All right, so now I know I'm going to be about 500 feet top to bottom, and I'm at 5,000, 5,000 in the middle. Now, that just sort of set things so I know about, I get a sense if I want to go 100 feet, I know I'll go about this far. So now if I've got a polyline, I'm going to switch my layer here. It doesn't matter. what it is, but I'll just do this, say C road center. And I'm going to draw a simple polyline. I'm going to go from here, I'm going to go from here, I'll go out to here and maybe up to here. All right, now that is, like I said, just a polyline. And I'm going to use that to create a center line. I'm going to turn that into a center line file. Now, if this were, say, a sewer alignment, I've got a manhole at each of these bend points, then, you know, I wouldn't have any curves. But right now, it's just straight line, one to the other. And what you can do with that is under our roads menu, we have a command that says polyline to centerline file. That means read a polyline and turn it into a centerline file. Now I can do a couple of things. I can put my curves in with a fillet command if I know what they are. Or when I built the polyline, if I knew I went from here to the PC and then I've got a command to make an arc, you know, I could have created that to begin with, or I could just go PI to PI. And I'm going to go straight to my roads menu now and say polyline to centerline file. And it asked me to tell it a centerline file to write now. See right now when I'm looking here at my folder as Carlson projects, that's because I haven't saved this drawing yet to a particular location, so it doesn't know where to go. And I'm going to either pull that down and switch to, now the last one I was teaching here was a civil class. So I'm going to hit my browse button and I'm going to come down here to where I've got my data in my 3D machine control class. And I'm going to give it a file name here and I'm just going to call it dummy. That's my center line. Dummy center line is going to go in my folder here. And I'll say save. Now it wants me to pick the polyline. So there it is. It shows me the direction it was created. And it tells me down here on my status bar that it should have been drawn in the direction of increasing stations. I have an option on my command line to reverse it if it wasn't, but if I'm good with it and I can give it a beginning station of 0 + 0, 0, that part's in angle brackets. So that is my default if I just hit enter. So I'll just hit enter. All right, and it reads some of the data and reports it back. And when you're finished with it, you hit enter to conclude. So now I have a centerline file. Now what I've just done with that linking on, first of all, when I select this and I look at its properties over here, I see that it is still just a polyline. There's nothing more to it than that. It's a polyline. But because we did it with the Carlson command, Carlson knows that I said a centerline. It's just a polyline I see over here. It's still nothing more than a polyline. But because I did it with a Carlson command, Carlson knows it's supposed to be a center line. So I can double click it. And instead of, let's just draw another quick polyline out here. If I double click this one, see what it does? It comes up down here on the command line with the polyline, with the edit polyline command. But because I turned this into a center line, if I double click it, it brings me up to the center line editor. The very same command, if I pull down the roads menu and choose edit centerline file. And I can look at any of these segments. I can zoom in and out. And I can change, you know, the point starting in northing and easting and pick a point. I can choose a different definition of road curves or railroad curves, you know, highway or railroad. But I can also, while I'm in here, I'm going to come down here and choose fit curve. And let's just say I'm going to put a curve of 100-foot radius in there. And if it's too big for what I'm doing, let's say I said 1,000-foot radius. Oops, 1,000-foot radius. It will tell you it's not, you don't have enough tangents left over to do that. The maximum you can get is 317, 5190. I'm gonna still come back here and leave it as 100. All right, it computes all of these, ready to go. And you can look it up based on speed tables. This is more of your civil design stuff. You as a construction company are going to really be putting in values that somebody else has already designed. So I'm gonna say, okay. Oops, sorry, it's 100. Hang on a second. I keep clicking. Oh. Now, my fingers keep hitting an extra button. Right there we go. So now I've done that. I've got a curve in there. I can edit that curve, change different things about it. I can go to my next line. Let's fit another curve in there. We'll make this one say 125 feet. All right, so now I've got a nice little alignment with curves in it. When I say save, it's updated the CL file. And when I say exit, watch what happens. It redraws that line, that alignment. Now, if I come in here and oops, that was too far out. Let me undo that. Let's change this. I want to keep it tangent. All right, so that kept it tangent. But I want to do something that's really gonna change the shape of that. So now I've changed my alignment graphically. When I go back and look at my editor, you see those changes were incorporated with what I did out there on the screen. Okay, so that is what this does when I say link line work with center lines, yes or no. If you say no, then what happens is if you edit that centerline file and you want it to replace it in the drawing, you have to go back and say, draw centerline file. And it would read that centerline file and then it would draw a polyline for you based on that. Okay, so it's just a convenience. I have never found a situation where I don't want to have it on. So that's what's good with that. Okay, now let's talk a bit about the modeling process and how we're going to work it. Let's go, let's see if I can find us a file. Switch down to now my see what I've got in here. By the way, if you look at these files in the data set that you download, I don't know that yours is doing this or not, but you see these dot underline in front of the file names. All of those files you can disregard if you got them. That comes from the fact that mine originated on a Mac. You may not see them because of not being on a Mac. But if you do, just ignore them. They're resource forks. They don't have any bearing on what you're doing. So let's look at, let's see, a good one too. Let's open up this demo 3 drawing. Now, this is a drawing that's used to give, this is to talk about the trenching module. This shows a little sewer line, 15-inch HDPE, 24-inch, comes down. It's how to build the trenches. We're going to ignore those trenches for right now. Look down here at this icon. I see my X and Y. I'm rotated a little bit. And you can change that if you need to or want to under the view menu. You've got this twist screen and you can just say restore due north. And when you put it back, it goes back into my world coordinates so that I'm on north. Now, what I'm looking at here, as I can tell, here's a contour that is on RDRF contour. And then I've got over here an EX contour. So I've got, let's see if that gets all of them. I'm going to go to view, isolate layers. I'm just going to pick one of those. All right, so that's all of them together. I don't have index and intermediate as separate. So I'll go now to restore my layer. So I've only got one layer that has all my existing contours. I've got another layer that has my design contours. And here is the basis of what's going to happen. If you look at these light blue contours, that's my design contours. And I see here's one that is elevation of 182, and this one would be 184. So that's climbing up a hill, which means that this is a ridge feature. Okay, so it goes lower this way, and it climbs up the hill. But now what's going to happen, let's say if I'm here at 188 and I need to go up to here, which is at 186. So I'm sorry, it's coming down. This is going uphill this way. So I'm at 186 going to 188. So halfway in between here, let me do this. Let's isolate these layers. All right, so when I'm looking at, say, from here along this line, if this is 188 and this is 190, then you would expect right in here would be 189. Okay. However, because when my triangles form, and let's say I'm going to densify this every 10 feet along this line, it's going to try to form a triangle, going back and forth across here. So it's going to go from 188, it's going to look across and go here to 188 straight. And yet it's supposed to be 189 right in here, and it's going to say it's 188. So that's the fundamental problem we have with these nose-shaped contours, and there's two ways around that. One is we could, let me change that. Oh, I've got that later. All right, so I could do one of two things. I could put in a series of lines, which would be called break lines. I'm going to say draw a 3D break line. So I'm going to go from, I'm just going to step down. Sorry, I didn't do that and get the right command through polyline. All right. So I'm creating this line that says, when I go to create this as my data, it says, okay, when I'm looking at this and the points along this line here, when I go to form triangles, I can't look across and see the points on the other side of this because I had this line in between. And that serves as what's called a break line. So it breaks the triangulation from one to the other side. That prevents that from happening. That's the best approach. I would need to do that. I would also need to, do them all down all of these little, I've got the center of the roads. I've got the face of curb, the top of curb, the back of curb. You see those little contours like that, that's stepping up on a curb. If you don't do this kind of thing, then it's going to jump across those things and make all of that flat. Now, the other option is under our settings, when we said minimize flat triangles. So it's going to try to not do that in here, but it's not perfect. Okay, so there's a couple of things you could go through, and this is a relatively small site. You could draw those in pretty quickly and easily and keep that from happening. So it would really fix these edges. Now, the better approach is in the drawing. If you have those already drawn for you, then you can use them. And even if they're not drawn, if they're just at 0 elevation, then you could draw them and tell it to, under our Elevate menu, 2D to 3D, based on screen entities. So it reads every time it crosses these lines and it puts the elevation into the line that you're drawing, creates that for you. So that's the better approach. The other one is that minimize flaps, right? So
there's really no real automatic way to have those break lines in there.
Not to make it magically automatic. That is correct. If the only data you have are drawn contours, sometimes you're stuck where you're going to get a less than accurate surface. But in this case, I can look at this and I can recognize the fact that that's a road. That the center lines are these points that point up like this. And over here is the edge of pavement. It climbs up to the top of the curb, goes flat back across to the back of the curb, and then continues on. So I would connect all of these central points. I would connect all of these edge of pavement points. I would connect all of these top of curb points, and then all of these back of curb points. And I would draw those lines in. Now what happens, you get a situation like this as you're going around. This is probably a circular arc that follows that, but I don't have anything that shows me that. With the only thing I've got are these contours. So again, sometimes you're just stuck with that's all that you've got. But usually you'll have that stuff drawn. And quite often they're drawn as 2D lines where you just select them and say 2D to 3D based on screen entities. And even if it goes around a curve, it's going to replace it with those segments. And every time it hits one of these, it's going to set the elevations, and it interpolates in between all of those things that it's set. And then of course, when it densifies break lines, it adds those points in there to create the triangles, and then throws them away. Or you could, here's a case where I've got a point here and it comes all the way up to here and there's no other points in between. So if I didn't densify these, and contours are going to behave just like break lines too, because this point can't look across this point on this contour can't look across this line and see a point over here on this side, because this line's in between. That's the nature of the way break lines are going to behave. By the way, when you go back and review this business here, it talks about break lines and how they're used. And like, here's an example of using a curb and why you need to use that curb, because you've got a situation where if you don't draw these lines in or survey them in or whatever, then, and you've occupied these points out in the field, you've got those elevations. Well, this triangle could form from A to E, and C could go up to G, in which case those are invalid triangles because A should come down to here and then climb up to E. Okay, so it should do something like this where it, there was nothing in between there, no other point, but it went down here before it came back up to E. So these triangles are correct. So, but anyway, we're not going to dwell so much on that. I want you guys to read that and study that on your own. So there's some really good discussion in there about how it works. Okay, so, but bottom line is be aware that that's a source of some potential errors. I'm going to go ahead and just take that out and show you the effects of that, even with minimized flats being on. So I'm going to say, I'm going to go back here now to my view. I'm going to restore my layers, and I'm going to tell it what's existing and what's designed. And this is where those colors are going to come into play. I'm going to right now, I'm going to actually just erase all of this stuff for those. The sewer stuff. I think it's all on the same layer. Yeah. All right, so I'm going to edit, erase by layer. And I'll select it from the screen. I'll just pick one example and then say, okay. And now everything there is out of my way. All right, so now this should be everything that I've got. Yep, that's everything that's in the drawing, or just a set of contours and a boundary. So on the takeoff menu, and we're just starting into lunch. I'm going to give you your full hour, but let me finish up this concept. It'll take about another 5 minutes. On this takeoff menu, when you have the construction module or our 9, 10, 11, 12, when you choose it, there's this thing called this project checklist. All right, so you have to do certain things. You have to define the targets by layer. You have to set a boundary, and then you're going to make an existing, make a design, and then calculate volumes. This tells you what's done and what hasn't been done yet. And notice it says set boundary polyline is done. That's because when this file was made, somebody had gone in there and chosen boundary polyline, set boundary polyline. So now this one is tagged with the fact that it's a boundary. So if you look at highlight the boundary area, see it highlight shows you what's been set, or you could even hatch the boundary area, and it'll show you it'll hatch up what's the actual boundary. Now I'm going to come back down here and erase the boundary hatch. All right. So just some visual clues. It's already done. If it had not been done yet, you would come down here to boundary polyline and you would set the boundary polyline. And it tells me down here now that one's already been set as a boundary. Do you want to clear it, yes or no? And you could say yes, in which case then you go back and just repick it again. So you can change that. And again, it doesn't have to always incorporate all of the data. It could be bigger, it could be smaller. You can actually have multiple boundaries to where you get pieces of disconnected surfaces. But anyway, here's the basics. Now, we've done that. We had that little checklist. Now, I've got a couple of other things that are going to be helpful for us here. I'm going to come up here. I'm going to right click in this gray spot, and I'm going to say show toolbar, Carlson. And I'm going to say, I'm going to come down here and find my takeoff. Oh, sorry, this was an
I'm not able to hear anything. I don't know if I'm the only one.
Oh, so sorry. I saw that it muted a minute ago and I went back to unmute it and I must have missed the button. Okay. All right. Thank you for letting me know. Can you hear me now? Okay.
Yes, I can.
Okay, good. Sorry about that. All right. So I pulled up these two toolbars. One is called Takeoff General and one is called Takeoff Display. If I can get the mouse up there. Let me exit that for a second. You see that one's called Takeoff / SiteNet Display. This one's called Takeoff General. So this over here controls the visibilities. This over here is our workflow. So we can import a PDF. We can do drawing cleanup. We'll talk about that after lunch. We can now define the surfaces based on layers, and we could set the boundary. So takeoff, and when I say takeoff, Josh, I mean the construction module. That's what I'm talking about when I say takeoff. The different approaches now, when I'm just under, say, civil, in my civil menus, if I'm going to make an existing ground, I would go to my surface menu and I would say triangulate and contour, and I would give it a name under this triangulation file. And then when I hit go, it asked me to select the things that I want. Then I would select all of these, these dark blue lines as my existing ground, any other points, anything that I have in it. But takeoff sort of clears all that up. As long as everything is on the proper layers, then it's going to read everything on those layers and create them accordingly. So if I choose that command right there is to define the targets, and it's there from the toolbar, the third one over, or on the takeoff menu. Let me go back to my construction module. There's takeoff, define, layer, surface, material, subgrade. I can come in here and I've got 3 different tabs. I've got existing, all the layers I choose here are going to be existing. All the layers I choose for here will be design. Everything else is other. So now that this other, there's nothing assigned here. So everything in my drawing shows up here. So what's going to be my existing, if I select my existing contour, which is what those blue lines are on, I'm going to come down here and say move to, and I can choose one or the other. So I'm going to move that to existing, and I'll hit the move to button. So it's now over here. Now my proposed grading was on, I think, C prop grading. I'm not.
It's on that one.
Yeah. All right. So, and if it's not, let's say you don't know where it is, or you make a mistake. Let's say we put this in design. Then all you do is come back over here, and now you can move it back to other. Okay. So that's one way to do that. I'm going to hit save and exit. The only thing I've done is existing, and notice it immediately turned green. Everything else turned that gray, and that's based on those colors in the settings. Now, there's another thing that you can do is, instead of just knowing what those are and picking them from the list, on our display toolbar, we have these 3 buttons, which are also under, we can set the layers for existing and design. And that lets you go through here and pick the layers for design. So now that was called RDRF Cont was my design. So if I go back to that list, I see it's now been added, and it had been taken out of this list. But now I still have this C prop grading. I don't know that there's anything on that layer. It may have been empty, but let me see if I go to my layers. I'm going to sit on that C proposed grading as my current. I'll select everything and freeze it except for the current layer. Oops. Yeah, there. So that's done now. Yeah, see, that was an empty layer. So that layer wouldn't have done anything for us. I'll now turn all my layers back on. And now notice that my light blue contours are now dark blue because that's what I set for my design back here in this business. Okay, so if let's make design sort of this orangey looking color. And now because I've made a change there, I need to go back to takeoff and just say update colors for set elevations. Did not stick. Yeah, there's design. This will be the orange. Return design off. There it is. Turn it back on. You just have to update it. So now I've got existing, I've got design. And again, that's why my colors can see in it. And if this particular, let's say these two contours were, let's say this one is supposed to be 196 and that one is supposed to be 194. So if these were, say, 0, I update for set elevations. Oh, part's not working. I hope it works for yours. I had to toggle that off and back on. Is yours working okay, Josh, on yours?
I turned that setting off because I didn't think I would use it.
Okay. So anyway, if I were doing like a PDF and I've elevated these lines and they turn green, but I know that I need to change those. So that was 94, 96. So I would go to elevate and let me look, assign contour elevations in series. And let's say I'm going to go by 2s. And I'm going to say start here, go to here. I'm only crossing 2. And my beginning elevation was, oh no. What was it? I forgot. It was 190. So 194, 196. So from here to here, starting with 194, it's going to change it by 2, up or down. I'm going to go up. So now it changed those and updated my colors. So that part's good. So now I've done, if I look at my checklist, I've defined my layers, I've set my boundary. All I need to do next is make these 2 surfaces. So you can either choose it from here, make existing, or choose it from the menu. So if I make existing, it did it. It showed me that it did down here. I'll make design. Same thing, it did it down there. Now, we don't see anything, but the surfaces are there. I could even calculate some volumes. I could go back to my checklist and see that I've done what I need to do. And again, I can calculate volumes as part of that, just total volume. Just take the defaults and say, okay. And that tells me I've got to cut this site by 37,000 yards. I've got a little bit of fill. All right, so that's quite a bit of haul away. So that's what we're looking at now. If I look at those surfaces, I'm going to go to my surface file viewer. Remember the road, which was part of my design? Now this file is called demo3. So I'm going to look at that demo3-FN. That's the final grade. I'll say open. And it's going to look like this. I'll turn the contours off. But you see those, even though I said minimize flats. You see those stair steppy looking things down the edges of my road? The center line of the road was okay, but coming up this ridge line, you see, I shouldn't see those sort of jangly looking triangles. Those should be smooth.
Can you display the triangle edges just so I can get a better picture of that?
Now you can see, because I densified, you see how it went across like that? So it put those every 10 feet, and that's why the triangles formed that way. Now, if I simply do this in my takeoff settings and don't densify, and then I go back to make design surface again, and then let's see, what did I? And then I'm going to put, this normally lives like that. There we go. So if I go back and look at that file name again, which was demo 3 final. So now you can see how these triangles, they don't go back and forth like it did, because it only went from, there's a point here. And if you follow this line here, there's your original contour. Here's the other contour. And so they had a point here and a point here, point here and a point here. So I got these two giant triangles out there. Now, in that particular case, what it looks like, you see, it's not quite as jangly as it was before right in here. I still got some stuff in here, but you do see that there's quite a few triangles in here because these arcs had those little segments across them, but it didn't densify. And that's why I like to, where's my stuff? Oh. There we go. Anyway, that's why I like to densify those things, because it smooths those out. And I don't have to worry about it. And I don't have to go in here and manually densify those contour lines or that data. So that's basically the process. You define existing, you define design, and then you make the surfaces, and you can do anything you want to with it. You can look at, if you go to the roads menu, you say quick profile from surfaces. Well, let's just pick a starting point. I'm going to say, I'm just going to go down from here to here. I'm done. And it's now looking at that. I've got the showing the original ground, the design, and the final.
In order for that tool to work, you have to have your surface layers defined, correct?
Well, you have to have built the existing and the designed surfaces. However,
work with 3D polylines, for instance, it has to be a surface.
no, that is correct. This is only looking at the surfaces. That command, it does work with 3D polylines in, say, civil. If I say quick profile, see, I can choose screen entities as a target instead of surfaces.
Mm-hmm.
And if I just use that and then say from here to here, then you're going to see quite a bit of difference. So yes, it's here, it's hitting. Let's zoom this in up here.
Like the peaks would be the original on them.
Yeah, down there's the design. There's the existing, back down to design. back to existing, design, existing, existing. Okay, and notice it's going point to point to point, and it straight line interpolates in between there, even though, and let's say if I run the command again, if I'm looking at surfaces, I can change, I can pick that sample line up and move it. So if I'm looking down, say that in fact, let me switch to the surfaces, and my first will be the demo 3 OG. And now let's say if I'm running this way, if I look at my design, well, it's doing it as a surface. Back one more time. Let's see, I want to let's just isolate these and and so now as it's crossing its straight line interpolation in between each of those. And if I look at it crossways, now notice when I'm here, of course, I'm at that, it comes down to that contour elevation. It goes flat across right in there. And then straight line up to here, straight line up to here. When it gets to that one, now in real life, that should go up and back down. But you see what it's doing? If I didn't have minimized flats on, and if I didn't use a break line, that's what my surface would look like right in there. In fact, to show that part, let's not densify and let's not minimize flats. And we'll build that one more time. Build my design. And then now let's take a look at our surface. I'll do that same thing. We'll go from here and say cross to here and then cross to here. So now the red line is my design. And I'm going to come up to here and I'm going to hit that contour right in here. And then I'm going to go across, and it's picked up a little bit of influence, but you can see when it goes from here over to here, it's basically flat. When I say minimize flats, it has that's why you saw the triangles forming originally. If I go back to my final, see that triangle in there, that becomes very, or these triangles right in here are the flat ones because there's your original contour. So it's run around here and it's created these triangles across, whereas really they should be going all in this direction like this. Okay, so that's the effect that those settings are going to have on how these things model. So I'm going to come back one last time and put these back on and then rebuild. And now I'll whoops, that's my existing. Let's add final. And then let's turn off. Oops, let's turn off my existing. Up to here, turn this off and back on there. So now you see, because I said minimize flats, it came around here, and instead of allowing it to go flat, it forced those triangles all the way up to the next line, which was the better thing for it to do. Now, what happens is when it forces these all the way up to that peak, you know, you could have done better by doing something like, you know, can't get those to, oh, I'm in the, get the right. There we go now. So I would right in here, you know, you can maybe switch out some of those so that you can minimize that effect. You know, but you know, you would wind up, you know, spending so much time and effort to try to fix these on a triangle by triangle basis that it's not worth, you know, doing it like this and trying to go through here and make those edits. What's easier is if you know what's caused that, and that's the fact that we didn't have break lines in here. And then so fix the problem that caused that to happen in the first place instead of fixing the results after the fact. So, you know, that's sort of more of the nuanced way of looking at what is going on with this as a model. But we have to, you know, learn to look at things in 3 dimensions. How, you know, we got stuff here. We've got, here's a case where, remember that that setting where we said extrapolate out to the boundary. Here's where our design ended, but it goes all the way up here as that, you know, it followed the existing out there to extrapolate back out. So there's a case where you might want to turn off that setting if you didn't want that to be part of this surface. Okay, so, you know, once we know what's going on and how to fix it, then there's a lot that we can do. We've got, you know, a bunch of flat things across in here. You know, is that truly flat, or does it go, you know, should these triangles all be lined up this way, in which case we would have, you know, need to put a break line in from here to here, which would have the effect of, if it's going to let me do it, let's say from here to here. Yeah, see, so maybe that would be, you know, a better implementation of that. But again, instead of going, can't do that one. Instead of doing all of these individual little triangle edits, we want to go back out to the original data, put that break line in, and then when it builds it, it does this automatically, and we don't have to go in here and make these changes over and over again. Okay. So that's what's sort of cooking under the hood. We'll come back and step through some more here after lunch. It's now 12:30, so we'll come back at 1:30. Actually take your full hour, so we'll make it 1:32. And any questions until then?
Looks good to me.
Nope, I'm good.
Okay. How's the pace? Are you guys real familiar with this stuff? Am I spending too much time on little things you want to move ahead, or are you learning things that are useful? What's the sense?
For me, I think broad strokes, I've got a pretty decent understanding of most of what we talked about so far.
Okay.
So a little faster wouldn't hurt me.
All righty.
Yeah,
How about you?
I'm good with it. The only thing I'm just on this R12 now, and I think you guys are on the IntelliCAD. I'm just a little bit slower at finding where things are compared, but no, I have an understanding of what we've done so far. Pretty good.
Okay, well, I'll try to switch over into the R version of stuff. The problem is that if I make some progress in one, it's hard to bring everything across.
Yeah, I know. That's not a big deal. That's all right.
Anyway, okay, now what we're going to look at here after lunch is the fact that like when we defined these things based on layer membership, that's all well and good. But one of the things that you can also do, and I like to do this when I'm doing my modeling, is, I may not necessarily just pick everything that's on an existing layer and hope for the best. I may go out there and build it individually with things on, with commands that are on my, let's see, I'm still in civil? Let me switch back. Let me go to my surface menu. See this triangulate and contour, and that gives me full and total control. And I can even give it a different name. But I can set individual boundaries and exclusion and inclusion areas. And there's my densify. I've got my minimize if I need to do that in here. I can even have it draw contours, whatever. And I'll give that a name. And so one of the options, and a lot of people that use takeoff don't or are not aware of, is that when I define this, again, it's meant to be layers based, but you see down here it says surface source. If you choose instead, you could build a file, or maybe you get a file from your designers or from your surveyors. You could say make the existing a file, and then you would select a file and you would choose, whatever file was done. And if you set that to there and then go back and make existing, all it does is read that file. It doesn't read this layer stuff anymore. Or you might not even bother to define it here. You may build it independently or receive it independently, and you can change your source to file. Okay. But the typical workflow is layer based. All right. So with that, we will come back now. Let's make it 1:35. All righty. And I will stop our share. And I'll pause our recording. Resume our recording, and we'll continue on. Now, you've seen basically these steps to, we have to build a boundary, and then we identify what belongs to which condition, existing or design, and then we build those surfaces. And from there, the rest is refinement, which we'll take a look at next. One option that I wanted to show you about was this drawing cleanup. This is a command. It's here on this toolbar. It's also on the takeoff menu. Called drawing cleanup. I'm not sure on the R series, Drew, but on the IntelliCAD, it's also on the file menu out here in the drawing cleanup. But what this command will do, if you are not familiar with it, is a whole lot of different things that can help set files that you get in from somebody else to help sort of, get it into shape for you to start to build your models. If you say, click on the defaults, these are some of the things that the programmers have thought might be good to do as a default. What they do is, if you get a bunch of files in, say from somebody that changes their coordinate system, architects do this a lot to line up with their buildings. So you can put it back to world coordinates. You can also convert architectural inches to decimal format, so that will scale things that come in if you know it's an architectural thing. So different things that you can do. Remove any empty layers. You can remove duplicate line work. Sometimes that's really helpful to clean up a file a bit. Text and points. Join line work with the same endpoint. So if you get like a bunch of contour lines and they're just exploded into those little bitty segments, you could say, go ahead and do that, and it would stitch them back together. Be a little careful. Sometimes if you get into an intersection where there's a bunch of things, it might follow the wrong path. So, some of these you can use with a little care. Erasing blank text entities, any fragmentary line work with a particular length value that you say anything smaller than that, get rid of. But one of the real things I'm going to clear, one of the real helpful things is if you get something in, it might have some bad elevations in it. If you turn on this set elevations outside a range to 0, it will change whatever numbers you type into here. Anything that's outside of that range, it will not erase the entity, but it just puts it at a 0 elevation. So sometimes, I remember I was doing a job out in one of the Dakotas, I think, South Dakota maybe, where I was training an outfit out there, and he was trying to model, several thousand acres. And he kept having problems and he couldn't see it. He always looked at everything in plan view, but what turned out is that he was reading some contours that somebody had given him, maybe from a quad map. And they were down, something at like 40,000 feet elevation. So they were really way off vertically. And it was causing him all kinds of problems when he was going to build the surface. So if he'd used this command, he would have seen those, flagged them, and put them all down at 0 that he would then need to elevate later, but at least he got rid of the problem. But one of the functions that goes along with that is this button over here that says scan the drawing. So it will scan everything in the drawing and it will read to you the minimum and maximum. Let's say if I put that back to 100, say I had scanned the drawing. Well, how come it's not reading my maximum? Huh. It's supposed to update that one. I don't know if that's broken in 2022. I think yours will probably work okay. Josh, if you do that, anyway, it will read you those numbers and tell you what the high and low is of any entities. And if it's within the range of what you're expecting, then you can leave it alone. You can uncheck it and cancel. But if you find some really weird numbers in there, then let's say you find some weird numbers. It comes up with something like 30,000, or this says negative 2250, something like that, then your site's up around 175. You could say maybe go from 100 to 200. After you hit scan, you read the bad numbers, put in a reasonable range, and then hit OK, and then it would take care of that. So I say, okay, now it said, it set 9 entities outside a different elevation range to 0. Huh. Those were those. Let me. where they went. Let's say 500. So up to about 200. Huh, got rid of everything. Well, reload this file to 3. Yeah, that's over 200. So now if I were to do that and say 100, 300. Yeah, okay, so we're in good shape. Now we're back to all that as well. All right, so that's just another useful tool that might give you some help cleaning up files you might get in from other people. All right, so how much, so how, do you guys do a lot of work with PDFs, or you typically get in PDFs and have to elevate them?
Yeah, both. Like we get some that supply DWGs, but more often than not, it's PDFs that I'm working in.
Okay, how about you, Josh?
We usually get DGNs. ODOT makes them use DGNs, so we have to convert those to DWGs. I'd
Oh,
say definitely more often than not we have a DWG.
What are you doing in terms of DGN? Are you going into MicroStation and saving them as a DWG, or are you using it in Carlson?
We have a Trimble Business Center that can convert them.
Ah, yeah, okay. So, and that's fine too, although Carlson can import a DGN. It does pretty good. In fact, it can even work directly in a DGN file. There's a few limitations with that, but the Carlson programmers spent a summer working with Bentley and vice versa on how to make sure all that stuff worked very nicely together. So there's some tools there as well. But if you're having a success using TBC, that's fine. Everything, gets you to where you're headed.
I mean, if it saves me a step, I won't complain, but there's got to be some reason we don't do it typically already.
Well, it could be that you're not aware that Carlson would do it or something, but that whoever's using the Carlson stuff may not be aware that it does it. But it's again on the file menu, and that's an import MicroStation DGN, and the other option is you can even open directly a DGN file.
DGN.
So again, you get very complex things. Sometimes you'll run into a couple of glitches, but even TBC may have some glitches on some of it. But whatever is your route to success, that's really the way to go. All right, so let's take a look at. I'll close this. I'll close this. And let's look at an overall workflow here. I'm going to open and be in my getting started folder that you downloaded. And let's take a look at our demo 1. Well, yeah, let's take a look at demo 1. Well, let me see. Instead of that, let's look at sample from T3 Global. Let's open that up. Now I'm going to go to my settings, Carlson configure takeoff settings, and I'm going to uncheck this assign color by target and say okay, just to keep all that stuff from changing. Now, what we have here is, a typical mess. I may go in here and do a drawing cleanup, scan my drawing, So 1279, 666 up to whatever this number, for whatever reason, it's not updating. I really have no idea why that's not. It's not anything I've encountered before. But I really haven't done much with it in the 2022 version. That is something I'll check out with Carlson tech support. All right, so another way I can look at those elevations is if I go to my 3D viewer in my view menu and I look at my drawing viewer and I select the things out of the drawing. This is separate from or different from the surface viewer, and it's going to let me look at this. And if everything looks to be, you know, if I've got the bounding box turned on, or if I say look at my color by elevation, if I see a reasonable range on my scales over here and a fairly even distribution of colors from low to mediums to high, then I would be pretty satisfied with that as something that I don't need to resolve. Okay. Now, this does not have any kind of design stuff in it, but if we were building this as our existing ground, what are you guys doing right? Excuse me. What are you guys doing right now to create your boundary? Are you just drawing a polyline, or do you?
That's what I do.
Okay. One of the things you can do now, you can certainly do that if you draw a polyline. We'll put it on a layer called, let me call it BDY. Oops. And I'll make it red. So you could, and I'm going to turn off my snaps. You know, you could certainly do something like this and just sort of draw your way around it. And that's absolutely fine. But if you get a lot of, you've got a whole lot of data that's got a lot of ins and outs, especially when it turns in on itself, that's going to allow triangles to form in this area here. And that's why you don't want to have the boundary to just go, you know, you could do something as simple as that, but you know, triangles would form in these areas. So you want to try to get those not done. So there's another technique under the draw menu. It says shrink wrap entities. Now, I want to show that to you here on this menu to also point out something. This command right above it, you might think that would be the command you would use, boundary polyline, but that is from the inside out. We want to go from the outside in. This boundary polyline would be something like if you had you know, something like this. And if you were going to hatch this area in here, so if you drew a hatch, you know, it'd fill up that hatch. And so boundary polyline, and that's a CAD command. It's not a Carlson command. But if I say boundary polyline, pick inside, and if I picked in here, then what it draws is the boundary that it finds surrounding the point that you picked with all those drawn entities. Okay, so don't confuse those two. Even though what you're drawing is a boundary polyline, but you want to shrink wrap your entities. And so here's your two choices. And I'm going to put this on my boundary layer. And I'm going to choose across gaps because I want it to jump across these gaps instead of turning in until it finds an edge. That's what bounded line work does. But across gaps, and I'm going to say my perimeter reduction, I want to show you the difference in what these all do. If I say none, and I'll just do a 2D polyline. I'll say okay, and then I'm just going to grab all my data and hit enter. And there's the resulting boundary polyline. It goes to the outermost edges, and you see it doesn't come in and walk close to here because I had 0 boundary reduction. I said no boundary reduction. Because how this really works is it goes ahead and triangulates all this data and builds triangles and then looks at these boundary triangles, and that's the amount of reduction. So if I get rid of all those triangles and then just take the outside edges, that's what I'm left with. So if I do this again, and I say draw shrink wrap entities, and I change that, let's say to high, and I'll say okay. Now when it's done, you see it comes up in places like this, and it, even though it jumps across the gap, it will come in. See how it came in here and then walked back out and came back around and came back out like that. So that may give you a little too jagged. It's certainly fine. It would work, right? So, you know, a good medium usually works pretty well. In this particular data set, setting it to low works pretty good as well. And you see how that now doesn't do a whole lot of stuff in there, but I do have a few things. Okay, in here, you know, you could clean up spots like that. You could even do something like this, convert that to an arc and tighten it up a little like that. You know, once you're done, and it doesn't matter however you choose to do this, to create that boundary is fine. Okay. So now that we have this data here and we need to build a surface from it. Now this is data that was compiled from a photogrammetric firm.
Does that shrink wrap go 3D or 2D?
It can, your choice. It can be either one. In terms of getting a boundary to build your surfaces, it only needs to be 2D, but it can also be 3D, so it doesn't matter. If you say 3D, it will inherit the elevations that it touches, just like drawing a 2D and then elevating it. It will take care of that for you. Okay, so now, this being data that was created by a photogrammetric firm, what we have, let me go to my inquiry menu, turn my drawing inspector back on, and I'm going to right click and choose just layer name. And now as I hover over these things, you'll see the layer names, and I see these white lines. They're sort of randomly looking, and they're on a layer called V-topo-BKLN break line. So the photogrammetrists have generated those break lines for us automatically. You see how they go down these nose contours? Same thing here in the roadway. You see those green contours that come up, and you know, if I look at that contour, we'll see right there's a break line that goes right down that nose and, you know, separates in between there to keeps those flat areas from forming. When they compiled their contours, which those are their drawn contours, they use these break lines. And they also use, if you can see these points, these little magenta colored points here, those are CAD points. So they compiled all that and they delivered that data. Now, what I would do with this in terms of building this as my existing model, I would say I would define my layer. Actually, I'm going to go over here and choose just set the layer for existing. I would choose that or define the layer, and I would pick one of those break lines and one of those points. And so now when I look at that assignment, I see that on my existing, I had V-topo break line and V-topo DTM points, okay? And so that's really all that I need to generate all those contours. But you might be tempted to say, use the contours to generate your surface. And if you don't use those break lines while you're at it, you're going to get those flat areas in there. And you can see that if I go now, I've got to set the boundary polyline. Even though I created it, I never told it which to use. So I go choose that command, I'll choose that polyline. It's now been set as a boundary polyline. If I next go and make my existing ground, it did it. Now watch what happened. I get this business. And this shows me I've got 11 crossing break lines and 2 vertical edges, and the amount that's in between, or I'm sorry, the amount that's in parentheses, that's how much difference in elevation they are when they cross. And you can see the little marker in the drawing says pointing to where those occur. So if I want to look at this one that's pretty bad, I'll select it, zoom in, and I'll see I've got a line that crosses right there. If I keep zooming in, see it's just barely over the, I don't know if I can even see it. There it is. You can see where it crosses. Now this blue line is on a layer called V-Road Outline, and that's a 2D polyline, and it's at elevation 0. So that's not going to be used, but this break line actually crosses that break line because when they compiled these, maybe this was already done or they went back and did this after the fact. So I've got a conflict there and I need to resolve that. And I either need to break this and get it away from that road edge a little bit, or pull it back and set it to the intersection, or whatever. So I would, really the quickest thing to do is to just break this off a little bit in here. And now there's that blue line underneath it, but this white line is now pulled back away from there. So if I do this again, that will go away. And you don't have to clear all these errors. Even if you just say exit, it's already built the surface. And it just, when it got to a place like this, it decided which one to use based on whatever algorithm it's using. So you're not sure what happened. Some of these, like within 100th, well, that's probably close enough. We won't worry about it. And those settings is where you set the tolerance that you're interested in looking at. Okay, so, this is just showing you the errors that you had from that information. But let's, now that I fixed that one, I'll go back and remake my existing, and it'll come back now, but that one will be missing. See, now I'm down to 10 and I no longer had that. So, but I still have a couple of these others, and you could chase those down and review it. However, if I view that surface now, which is called my sample from T3 OG, that's my original ground. That's what it's going to look like. And if you look in here, you can see those break lines that went down that road edge, nice and neat. I've still got a couple things in here that weren't necessarily compiled totally correctly, but pretty decent. And I look up in here, I want to show you the difference here in a minute. You see right in here, there's a little area that's actually a loading dock. So it was modeled, and there's a break line and a break line drawn in the data set. So it was done pretty nicely. There's a couple little gotchas over here. But anyway, this is defined that. I've got my curb edges all show up nice and neat. So it's pretty nicely defined. Now, if however, if I go back to I'm going to set my existing stuff, I'm going to select these. move them back to other. Save, exit, and I'll now set my existing. And let's just say I'm going to do it just from the contours, because again, sometimes that's all you get. So I've got those. I've got one of the one of the index, one of the intermediate, and then over here in the obscured areas. So now I've set those. If I look at that, you see I've got major, obscured, minor, and minor obscured. So if I set that and now build that surface, I'll not get any errors because none of those contours crossed. But if I look at that surface now, look at the difference. Now remember that loading dock over here? So let me turn this. So you see over there, what used to be a nice, well-defined loading dock has now jumped out. I've got some really weird things going on. Look at it. Look at this mess in here. See that stuff's not there, even from my drawn contours, which were this thing too. Just add some of those contours. So you see the drone contours were these green ones that you see, but you can tell. See that contour that wraps right around here? Can you see that color? And then,
Yeah.
and then this one over here, and they just sort of stopped because there was something in the way. But because that's the only data it has, it fills that in with this false information. And it winds up displaying contours that look like that. When I display these contours, that's just contouring my surface in memory. So you can tell in this particular case, it's much better for me to use the break lines and the points that they used to build that surface. Otherwise, again, if I look at this with minimize and densify turned off, and now built that surface and then viewed it. You can see down the road edges, you see those stair-steppy looking edges instead of those nice crisp break lines. And I can't even tell my curves at all because those break lines are not there. It's only reading contours. And that gives me this loading dock over here looking like a ski ramp. Okay, so you get the idea. So know your data and what's going to give you the best definition of that data. And again, sometimes all you have are the contours, and I understand that, and that sometimes that's all we can do, and we just live with it. And hopefully we're not doing work over there, or we need something to help us define that information a little better. And that's what these break lines are, these building edges, and those, you can see all these little points that show up. Okay. So there's a couple of techniques and tools and tricks. Shrink wrap to set your boundary. understand what is creating the data and look at your information and see if you have something that's going to help do that along the way. If you get a file in from some of your engineers, and if you got a nice finished drawing, make sure you go and check your layers. You might have break lines. It might come to you like this, where it's frozen, not break line, but was it V topo break line? Maybe it shows up like this, and the data's there, but it's frozen. So all you see is that, and you don't know that it's there. So make sure that you look at everything that comes at you and see if that's something that you can use. Okay. Now, let's step through a couple of things here. Let's see, Drew, you said you do sometimes bring PDFs in, and let's take a look at that. I'm going to go to a new drawing. I'm going to use that template. I'm just going to come in empty. I will give it a name. I'll choose set. Go to my 3D machine control class, and let's go to getting started, and let's call this one a class example. We'll keep it at 50 scale is fine, or let's make it a 30 scale for better. And then we'll just take our defaults from new coordinate file, and it's empty. So now I started my file, I've saved it, given it a name and a location, and I'm going to bring some data in. So one of our first steps here is to import a PDF file. And that would be, well, it's on the toolbar. If we look at it on our to it here.
Maybe I'm getting ahead, but is there a difference between importing a PDF and attaching to PDF?
Yes, and I'll show you that in just a second. Put this one and call this R11 demo. Say okay, and I'll say, yeah, no projection, that's fine. All right, so I've got one started here. I'm trying to find out where your command is. Now, this is my reports. Right now. So it's on your toolbar here is import PDF, and under takeoff, it may be under the, yeah, it's under file PDF. No, that's for your output. Never mind that. We want to import a PDF file.
Yeah.
Okay. Now, the difference between doing that and attaching a PDF, when you attach a PDF, you just get the image in your file, and then you have to draw over top of those images. Okay.
If I'm not seeing the command for importing PDF.
Okay, for you, Josh, it would be, well, again, on the toolbar there, or under, should be import. No, it's not there. Let me see. Oh, by the way, you had this other microstation DGN. That's another way to get a DGN file in. Let's see, where do we put that here?
And maybe you mentioned if you attach it, you have to draw over it. But the way I typically do it is that I'll do a PDF attach, and then you can actually explode it, and you get line work from it. Is that
That's, well, that would not necessarily, that shouldn't actually work. It should, I mean, if you have a scanned PDF where it's just an image only, then that won't.
I see
explode.
what you're saying. Yeah.
But if you have a vector-based PDF, then that may, that's something I'm not aware.
Yeah,
of.
most of ours are vector based.
Yeah, so that might work as well. Let's see, why they don't put this out here on these. I mean, I'll show you where it is as well.
What's the keyboard command? There's got to be a way to do this.
Oh, certainly there is, and it's PDF attach, I think, or let me see, PDF. I import, and it's not here. If I say standard import, if I choose this, file
Yeah,
node,
there we go.
let's see, is that on here? Yeah, there's a PDF. So you can do that. Now, when you do an import, a standard import, and if you do an import, let's go to this example. Let's try Family Dollar. Let's look at the plan PDF and say open. Then that will bring this up, how many pages you want to it or which range of pages. And now PDF data to import. I want to bring in any vectors, and these are all vectors. I'm not going to do any solid fills. And if I have true type entities that are invalid, it will bring them in as you get the text as drawn lines, or any true type text as well. So different things, rasters, no gradient fills. And then you could just bring it in as a solid block, or go ahead and join up the lines and arcs, apply line weights. If they're heavier lines, it will apply them, yes or no. Layers, if this is made and saved layers in the PDF, it will use those. Otherwise, it will create layers based on color usually, or just put them in all in the same current layer.
Is it typical that I wouldn't have as many options as you guys would for this?
I also do not. Mine just comes in.
Okay, so you would have, if I go back to dollar plan. Yeah, you
And
can.
that's what I have.
Okay, so that's new in 2022, apparently. So Josh, yours is probably also like that. So here's your options: line work, use colors for layers, or if it had PDF layers, that would be active and you could use those. And then you could edit the table and, put a layer map, that sort of stuff. Here's your joinings. Yes or no with line width. I'll just leave them as zeros. Skip over any little ones. A lot of those are things you can also do in the drawing cleanup. And then if you have images, which you could just insert it straight as an image. And then there's this vectorize and insert. So that will actually try to read the image, the dots in the image, and create line work out of it. It works fairly well, but sometimes, you get a little stray dot, or if you've got a scanned image and the paper was warped a little bit, it's going to do that to the resulting lines. And then on the settings, just as to which engine to use, this one is really works better than the Go script, but it's there as an option. So that would be, once that's done, you would insert the line work and it does the conversion. Pick a point to insert it. I'll click it here, set my rotation. You can set a one-time scale, or if you know it, and I don't remember what that one is, I think it's 30, but we'll see. All right, so there it is. I'll then zoom extents.
Yeah, so mine, it just skips to pick an insertion point and an angle and stuff. I don't have any of those option boxes.
You didn't have any of that? The line, image, and settings?
Nope. And that's just going through standard import, selecting PDF files and picking one.
All right, now, once, did you go ahead and do it and you have it in the file now?
Yeah.
All right, does it extract them out as individual lines?
Yeah,
It's not just an image, right?
correct. They're lines. It's all in like 0 layer though. I don't have anything like you're looking at.
Okay. There's an example of that text. You see, those are just lines, they're just polylines. They must have updated some of that in 2022. There's another module called, and I can't demonstrate it because my license is not covered for this. It's called CADNet, and that has a lot of that raster to vector conversion stuff, tools that are built into it. That may be something that you might want to look at. Let me do real quick. CADNet. I'm talking about the new ones. So we see, we'll take, let's see. Huh.
Like I said, we don't do too much with PDFs, so it's not really a big deal for me.
I was just trying to see all the things I can tell you it can do. A lot of BIM support and stuff like that. It can automatically search things out for you there. Now, if I'm back in the IntelliCAD version, and we just did a standard import, and that's where you said you didn't get that other
Correct.
option. All right, so now the other thing was, if you did a PDF attach, or you do, I don't think XREF. Yeah, that's only for drawing data. But if you do PDF attach, and let's go now to my,
You see, when I attach the PDF, I can see the line work layers and stuff before I explode it. That's really interesting.
yeah, if I go here to external reference and attach, and choose a PDF, get plan, one page, insertion point, scale it at 1, rotation. It's now attached. And I'll zoom that in like that. But you see, when I look at that, when I attach it, it's just an image. See, it's a PDF underlay.
Right.
So it doesn't now, all right, so that's now just an image. Now, if I explode that, wow, you know, I never knew that it would do that.
Yeah. So that's what I'm getting. Either way, I've done it so far.
Yeah, well, that works. And now if we're going to scale everything, what we would do is we would, if you look at this and see that's supposed to be 30 feet. And so if I measure from here to here, you know, that's just 1 inch. So 1 inch equals 30 feet. So this needs to be scaled up 30 times, or I could simply scale everything with the scale command. I'll select all, select entities, all, give it a base point here, and I'm going to say by reference from here to here should be 60. So now when I do a distance, 0 to 30, reads 30. Okay, so that one had to. Now, everything here is at, see, that's supposed to be 785. It's obviously, it's a 3D polyline, but it should be, it should be a 2D would be better than a 3D, but it has 0 elevation, so I need to elevate that. So that's interesting. It pulls everything out as a 3D. Oh, yeah, see, everything's 3D polys. Now, when you do that, Josh, and you bring those in and you explode them like that and you get a 3D polyline, what do? Do you just go through here and set that elevation?
I would probably do a drawing cleanup, so all those join together, and then I would set the elevation by series.
All right, so when you do
You'd
the,
have to delete some of the stuff you wouldn't want, and break things, but yeah, it's a lot of manual work.
oh yeah, there's typically that. Now, if I did that drawing cleanup and it joined these, my question is, does it make that? Oh, it does make it a 2D polyline. Okay, so that part does it. All right. Yep, that would work. And again, you've got that layers, it's all layer 0. So you'd probably assign everything, put them on the right layers, and so you would say maybe set this on a layer. We don't even have any layers. We started with 0. So if I open, go back to my recent. Let's do that. Dirty open. So if I look at that, it's already open. Oh, that's my file here, sorry. If I open up the just use civil demo. I'm only going to do this so I can take some layers across. Close that. Now, if I select this and I put it on a layer called VTopo minor, this would be on VTopo major. Change the color of that. VTopo That's what major. Then I would go typically to my match properties and I would say, grab that one. That's 90, 85, 86, 70, 80, 90. Let's see, here's 80. It's really the only ones I can see ever since then, 8, 9. 2, 3, 4, 5. um, 75, I don't see out there on the front anywhere. And then maybe do these others for these to get them. One of those is probably a major, but we don't know. I'm just going to set the rest of these. Accordingly. All right, and then let's see, we would set probably that one. It's not a contour, that's a sidewalk edge. All right, so you would do something like that. You would set your existing targets. And now you notice with that color turned on, let's see, I need to make this one also. Oops. They're red, and then when you go to elevate these 85 to 90, elevate, sign in contour elevation, multiple in series. I'll go by ones. I'll go from here up to here. For instance, starting with 785, go up. So now they've changed, and I can look at this and then see, because I've got that color assigned, I know which ones to go to next. Now here's, for instance, 76 up to 84. So if I do that again, start from here, go all the way up to here, and start with 776 and go up. So they've now been changed accordingly. And they take back on the original color of their layer. Now, that color is being controlled right here because I am automatically updating the colors based on the assigned colors by elevation. That's why they were red. Once they have elevation, they go back to the color that they're supposed to be, in that case by layer. If I have this on, then those would all turn this green instead of those original colors. Okay, so I'll leave that off just to show you that that's the process whereby you're going to go about doing those. Same thing, here's a finished floor of 776.70. Well, then you would, maybe take these polylines, or at least just the outside edge, the outside boundary, and this polyline, set the elevation to 776.7. And, those would also be in, well, we have to put them on a different layer and then set that layer for design. Okay, so again, as you're familiar, that takes a little bit of effort in building this up, but that would work. But then you still got some work involved in, let's say if you go to build, these are the actual design contours, I think. So if you go to build that surface, you still need to have break lines going, well, in this case, no, because that's a contour that loops back on itself. But say from here, down to here, down to here, you need that break line in there to keep those flat areas from forming. This particular little site's not all that problematic. Now, you do have a case where here's the 777 contour, it hits here at the ground, and it works all the way around here. All right, so you know that's a wall. And then there's a 785 across the top here. Don't see, there's no other, or the contours that would set for that particular line, this outside line, it would be reading the elevations of where these contours hit it all along those edges, and here's on the inside as well as the outside. So that's our retaining wall. We would convert that to a 3D based on screen entities, and it would read those elevations and create that. So 2D to 3D by screen entity. Whoops, set these elevations over here first. So this is 776. I just select those and make them 776 by properties. Now, when I do it by properties, I do a CAD command instead of that Carlson elevate command. I then need to go and update colors for set elevations, and that's when it rereads them. All right, so now here I'm going, what is this elevation? Is 788. So I'm going to go elevate contours, multiple in series. I'll start here and just go all the way up. I'll start with 777. Go up. So that's now been elevated. This one, see, this one is 788. That's probably 789. As I loop back, this one is, there's 788. This contour map's probably not drawn correctly. This comes all the way now, wraps here. Unless that's the top of the wall, then this would be going back down. So if that's 788, this would be 87. That's 88. That would be 787. This one is separate at 786. I'll update my colors. This one needs to be on this layer. All right, so I've got one more here, that's 785. First I will join. Oops. Then delete that segment. That's now 785. Update my colors. All right, so now I've elevated all my contours that I have, unless this is contour data here. Which would be 776, maybe let's say that's 775. 775. And it's on this layer. So 75. Again, here's another contour, which has got to be 776 to go to 777. Again, it's on this layer. Yeah, could. Don't really know. See, this one comes around to here. Well, there's a contour. So 770. All right, no. Got some of these contours that come up and hit the back of curb. I don't know if it's not that. That goes all the way across this, you know, whether it comes up and wraps around, you know, and right now I've got a conflict right here between that one and this one. So, you know, so you fix those. And then to elevate that wall, I'll do a 2D to 3D by screen entities. Keep that, and I'll put this on. Break lines is fine. Here's what I'm going to come. So that one, I'm going to do this one. And now anything I want to use, I just say all, anything that's got elevation. It's going to read it. It's now elevated. And if we look at all that stuff, you can see in 3D with my 3D viewer, you can see there's a case where, see, it read the tops and then it read the bottom. I've got this line here, looks like it's probably bad, as well as this line back here. So I would need to resolve those. That wall, here's the bottom of the wall down here, the top of the wall up here. And how you normally set that up is, or now we got a base and it slopes all the way up to the top. I would go ahead and build the top. So I would have broken this thing apart, set the bottom and set the top. I would have taken the original file. Let me get rid of these 3D things for the moment. Not this one, just this one. So I would have taken this and see, so that could be, let's see if this one is contour edge, right? So that's the And that's the top. I would have found all those tops, strung those together, set them by crossing entities. And then this bit in the middle here, that's the offset from this bottom line. That's a contour that's wrapping, but that would be the bottom of that that wall. Let's see if I've got more than one here. No, just the one. And so once you get the top set, I would have offset that wall width at that same elevation all the way around, and then the bottom has the foot, and then I would connect up from the bottom to the top with those little connectors so that the original top see this as the top of the wall would be actually possibly a separate elevation from this line, which this walks the ground. So it starts high and it walks down these contours and sets them correctly. Now there's that one. This contour line should have gone over here instead of walking back this way. That's what happened when I joined those lines and it didn't know which one to use. It picked up the edge of the sidewalk instead of joining to this contour line here. Same thing, there's that other edge of the sidewalk. So I would fix that as well. But that original wall, when we set, find the damn thing again. Oh, sorry, I'm over here. When we set that to read these entities, it's got the ground on both sides, but then the inside part and the ground on both sides is actually this line and this line. But then this part, you know, if there's any height to this wall at all up here, you know, that it comes down the ground, it comes down that slope, that wall might follow down that slope, possibly does, or it could be, you know, it could be stepped, it could set at the same height so that you've got some kind of a height of wall down here that, you know, we just don't know based on the data that we have here. It's not showing anything. What we would assume from that is that the top of that wall follows the ground all the way down, but then walks around this inside down here. But when we did that originally when we elevated it by screen entities, shows everything. So when we that's why you're not, you know, we're assuming the top is the top here, and we would just offset it that width, and we have a near vertical face of a wall, which you're not seeing any of that here. So when we model this, it's going to actually put an inclined slope from the foot over here all the way back to the outside edge of that wall. Okay, so quick fix on that is if I select that and I go to my isolate by selection. So there's now the wall, but it goes, you know, there's ground elevations here all the way to the top. So what I'm going to do is I'm going to break this apart. And I'm just going to break it right here, and I'm going to say F for first. I'll go to that import, and then the second I'm going to say at. So it's now separate from the other one, which comes around to here and stops. So I'll come down here and do another break at. So I'll break this first point here, the at symbol, to use the same point. So now I've got this by itself, and then I've got this. They're all along the ground, but I want to make a top of the wall so that this wall shows some thickness. So I'm going to do a 3D offset, and let's see if I can find it on particular menus. I don't find it there. It's going to be under Edit, 3D Polyline Utilities, Offset 3D Polyline. And I'm going to use this interval method, and I'm going to change layers. I'll say okay. Now I'm going to tell it a horizontal offset amount. I'm just going to go 1/10, 5/100. And the vertical offset amount is 0. I'm not going to change the elevation of this line. I'm just going to take it and set it to the inside here so that it climbs up and goes all the way up to that edge there. Now I need to do basically do that same thing now, but going over to this other almost inside edge. So now I'm going from here and I want to go across to about in here. So I need to find out what that distance is. So if I'm going from here to the, oops. Let's go from draw 2D polyline. Trim. All right, so that distance is a little over 1.05. So if I offset this one with my 3D poly, I'm going to go a distance of 1 foot this time. No vertical. Go from here to here. Except now I need to come down and get rid of this little guy here. My extension's not working. Fill it. It's not going to let me. It's 3D. So if
Drew can comment on this, but I think we get the point conceptually if you don't want to go through all the meticulous details of updating things like this.
Yeah, I'm good with that.
that's it. 8.78. That's it. 9.01. So I'll select that and bring that guy up to the location. All right. And so I didn't join those up over here. So anyway, you get the idea. There's a bit of work involved. Set that up, do the same thing here. You know, and that would follow all the way around. But what I would do at that point then is get my current, make a 3D, go from corner to corner. So you can see the result. So then when I look at this, and you're going to see some mess over on the side, I didn't finish that up, but so now when I look at that as a structure, you can see now it's quite readily a wall. So, but really what I would have done, instead of assuming that just followed on the top, I would have expected to have top of wall elevation so that out here on the face, this outside line follows the ground, but there's a little bit of height on that wall out there. So I would have inset the original outline just enough to define the height, set the outside edges to the ground, which is what we did with that contour. And then established that inside, and you can see right in there's a problem out right in here where this would jump down and follow the contours, which I may or may not have set correctly. And so in fact, you know, some of these contours might be misinterpreted, but you can get the idea of the process and what you need to go through. There's another, see, I didn't have the outside. Well, that outside actually stops out there. That's the ground out there. The ground in here, and it comes up, but it forms a nice, not just a nice picture, but it's also helps the modeling so that it comes in here and actually builds that as a three-dimensional structure. You can see in here, it didn't actually find anything across the tops. It missed these edges when we went to elevate that. Okay, so that's sort of some of the work that you got to do with these. When you bring in the PDF, you have to interpret. You sometimes might need to call these guys back and find out information, or like I said, preferably you can get the drawing files where they've got everything that you can build this from, or even more ideally is if you can get them to share their surface data with you. And do you guys get that from any of your providers? Do you get them to give you surface data?
Most of our designers design in 2D, so they don't even have them.
And if so, how are you getting that?
I'd make it myself.
Yep, that's what I do as well.
There's so much height, that's gonna be 2 inches above that bell, be 6 inches above.
But If they are amenable to sharing that with you, which I said a lot of times some of these engineers are not, but if you do, then the best way to do it, if they're not using Carlson, is when they send you that information, is you want a land XML file. Okay, and so that's this option right here. And land XML, sort of like a DXF is to CAD. It lets various CAD programs of different companies exchange data because it's an agreed upon format. But land XML is in extensible markup language. It is XML data. But land means it's going to provide land development type data. It includes points or coordinate points, you know, like a Carlson point and a Civil 3D point. It includes surfaces. So whatever form their surface data comes to you, if they have exported a land XML file and send you that land XML file, when you read it, it will offer to save it as a .bin, as if you had built the surface yourself. So it includes points, surfaces, pipe networks, parcels for like subdivision work, alignments, and profiles. So center lines and profiles, all of those things can be transferred over through land XML. If you can get that from your providers, then your work gets cut way down. You don't have to build that stuff yourself. If you have a case where your engineers are using Civil 3D, if they just give you that Civil 3D DWG file, the DWG file has all that data already in it, in which case you can import Civil 3D and you can bring across these objects. But that would also be these points, center lines, any line work, pipes, surfaces, and in this case, labels. It just converts it to text.
Does that mean if I were
So
to,
those tools are also available under the surface menu. You've got some surface utility. There's import, export. So you can get those in a TN3 file if you're using, I think that's TopCon, if I recall correctly. You can bring a Google surface in, a land desktop or Civil 3D surface drawing. You can convert those extended entity contours that you get from land development desktop. That's sort of an old one. Here you can export Trimble and TopCon surface files. That's what you would actually send out to you. What equipment are you guys using, Josh, when you're your heavy equipment? What are you using for machine control?
Trimble?
TopCon, Leica.
We use
Trimble.
Leica.
Okay. Josh, I don't know if you're still there
Can you hear me?
or what.
Yeah, I can hear you. He said
You
Trimble.
build your surfaces for machine control. What kind of controllers do you have out there? What kind of format do you provide?
He said Trimble. Can you hear me?
The dozers.
I can hear you, Drew.
I can hear you, Josh.
Can you not hear me, Ken?
Ken cannot hear
I'm not
either
hearing
of
you,
us.
Josh, if you're talking, the little highlight goes around your name, but I'm not hearing it if you're saying anything. Okay. Now, Andrew or Drew, do you guys, are you preparing surfaces for machine control?
I want to. Can you hear me, Ken?
Josh actually left us. He may be rejoining. All right, Drew, how about you? Yeah, there's Josh back. Okay. Oh, Drew's left. All right, so Josh, you're there?
Yeah, can you hear me now?
What's going on?
Can you hear me now?
Now I can.
From business then, yeah.
Yeah, okay, so you're actually putting Trimble files out there on your equipment, so
Yeah.
there's one way you can do that. Okay, Drew,
And that's one of the reasons we have the Trimble Business Center, because we take our XMLs and we put them in there and they'll make them TTMs or something. I haven't gotten that far in the process yet. I was hoping that's what you
I
teach
see.
me.
I see. Okay, so when you have those surfaces that you're going to do it now, when you guys put those surfaces on your equipment, do you typically, and this is where Takeoff really differentiates between some of the other products like AgTech, when you put that surface into Trimble Business Center or whatever, the ultimate thing that goes on the equipment, is that typically just the top surface? And then let's say you're grading a road or a parking lot, and so you got the grade down to the bottom of the subgrades? Do
Yeah,
you,
we actually typically do like the finish grade, and then we'll offset the surface 10 inches
Yep.
or whatever we need for.
That's exactly what we do as well.
all right, so you offset the surface, or sometimes you can even just go into a dial down on the blade.
Yep.
On the
Yep.
blade. And that works and all that, but when you do this with Takeoff, because you're able to accommodate or to account for those thicknesses, when you're building the surface, you don't have to do that adjustment. You can actually send out the subgrade. So
Surface.
yeah, so you send that out as a surface because it's not, it's not going to be 10 inches everywhere. You're going to have to decide where it drops down and by how much. So it's going to accommodate those different areas. Now, to show you a couple of examples, if we look at let's see, come back to this. See which project this was. I think that's the right one. Yeah, so here's a series of files. This is the existing ground that was modeled. There was a parking lot sitting up behind a large building down here. And then let me do it this way. All right, there we go. So there's that original ground. This one is the finished grade, but with subgrade. So you can see in these areas, like right in here where there's topsoil replacement and the planter beds. And then I've got the parking lot. You can see it's dropped down to where the subgrade of the parking lot would be before it comes up to match the building footprint. Same thing here. You can see where the curb's going to go in, but this is extra, there's extra depth in here. Same thing over here. There's a drop down in that area for the concrete pad. You can see, again, the varying topsoil grades. Same thing from the street. There you can see the sidewalk because the sidewalk slopes down. All right, and then finally, this is the final surface. This would be what you guys are typically then doing a dial down on the blades to work with. There's some reports, etc. Take a look. And so that's really the advantage of using Takeoff, because it will accommodate and account for those subgrades. And you can just send that surface out without having to drop it and, okay, in this area, you're going to be 10 inches lower or whatever, because it's not a universal drop. Now, you can still do those things. So like on triangulation file utilities, if I you can still, there's that one we did earlier this morning, but you can still say, take this utility and then you can subtract up here and you can, take 10 inches down off the surface and that would be that subgrader. So, you have those tools still available, but with this as an option, you're going to be able to accommodate those subgrade depths. And let's take a look at some of that. Let's go back to, I'm going to close this. And let's open a file here. And let's go to the folders that we got. Let's look at this Guardian surface and let's look at the C200 grading plan.
Now, when you get errors like one or more SHX files are missing, do you just ignore them usually?
Usually what that typically means is there's a shape file that's missing, and it means that you've probably got a line style that is dependent on a particular shape file being located and you can't find it. So your line styles might not show up correctly. Like if you've got a line style that has a symbol in it instead of just a letter.
Right.
So it's not going to show those correctly. So that's generally what it means. But otherwise, you could say replacement, and it will step you through each one that it's missing and ask you for the type that it's looking for up at the top of that little dialog box. That'll tell you which one that you're trying to find. So it might be in a different location. All right. Actually, so this is not the file that we needed to open anyway. So sorry about that. Let's go instead and let's look in the Guardian and then look in the working folder. And we've got some base info. And then I've got these different, let's see, there's a site plan. There's my PDF conversion, stage 2, stage 3. EC existing. All right, so if I look at my base info, let's just talk about what's gone here. This is the drawing file that was created when I imported that PDF file. You see, it just brought in these little unelevated, dumb little things. And like they have a bunch of drawn contours as dashes. I got this, what used to be crosshatch filled. There are all these individual little lines. So, we would take all that stuff out. You got to put them on different layers. A lot of work. We're not going to go through all that, but how do you handle that? If I want to turn that into a continuous polyline, even if it was a dashed line type, again, with drawing cleanup, you've got this thing where you can say join line work with the same endpoints, but they don't have the same endpoints. So we need to join those another way. And that's done on our edit menu, polyline, or not polyline utilities, but join nearest rather. It's also on our polyline toolbar. So join nearest, and you need to give it an allowable gap and say, I'm just going to show it that distance. So anything with that gap, I'll directly connect, convert to a polyline, join only, same layers, same elevations. And then if you do, a couple of things like this, you see it, apparently I didn't select that part, but it took that one and converted that into a continuous polyline, which I can then change the style of that line type to be to, I need to change its, let's see what. Let's get back to scale. Yeah, let's make it 1. Then it should have a. So let's make 0.0. Make it, let's make it 0.5. Let me get a decent interval on this thing. Point. All right, so there. So, you know, that's still a continuous polyline, but it's got the advantage of the gap. Now, that's how these were originally drawn, I'm sure, but when it came in, it exploded everything apart. So that's part of that effort that you would do. Now, another thing that you would do is when you see these contours coming in here and hitting these curved faces, I would take these pieces of curve and I would elevate them based on when it reads that contour. So I would go back to my elevate menu, 2D to 3D by screen entities, and let it read where it crosses. Now these have to be at elevation, of course. So that's essentially that process. And it took some doing, all right? So it took a bit of effort. Now, if we look next, I'm going to close that one and I'm going to open up another one now. In that same folder, the example 5 Guardian working folder, and I'm going to look at the E, which is the converted file. And here's where I've elevated. So there's a continuous line, and it's at, that should be at 1150 elevation. You see over here it is. So that one's been elevated. You can see everything that is elevated and check for any problems. So you can see, you know, I elevated the curbs. Around the buildings. Right in here, this little, see those contours there? There's a little concrete ditch that comes and drains around the back of the building. All right, so put those in. You see these blue lines? Those are the break lines that I drew in myself so that it wouldn't make flats across there. And, you know, here's a case where when they drew the contours, they just stopped at the top and stopped at the face. The assumption being that it climbs up and comes out the top. Now, I would also need to look at that and see, was that intended to be a, you know, like a roll curb or an asphalt wedge curb, or should that have been an offset of, let me go say 0.45 away here. And now when I look at that structure, needed to get bottom. Did I get it? That's something in there. Let's see. That's a 3D. at the 2D. So this has a 3D polyline. If I do that one now, edit. I'll say 3D and say 0.05 and raise it up half a foot. I'll take this one. All right, so now we should be able to see those. There you go. So that's how, if it's a square curb, you may have to do that. We get the bottom, we get the back, and if we need the top to make it a square curb instead of a roll curb, we have those tools to offset that 3D polyline. And you go through here, and after you've set all these things in elevation, you create that, and then you make those you put them everything up at 3D that you can help. Now this is the existing condition, so we did all of that to make that existing ground. Then this business in here, which you can also see over here, let me change. I don't know what. I don't know what we had. Yeah, this will make it look all black, but in any case, we had in the original, we had these areas drawn. This was going to be the topsoil replacement. This is where everything inside of that is grass. So we created a polyline around it all and said, all right, that's where you're going to put your topsoil replacement. And again, or I'm sorry, not replacement, but stripping, because this is our original ground. So out in here, we're not doing any work. So that's going to stay our original ground, but we're going to strip topsoil in all of these areas because our final design, that's the outline around the final design, the final grading, which you can see by match. Oh, I'm in the wrong file. Sorry about that. All right, so this would be our grading plan. So let me use that. All right, so now you see these contours that you see running across here. That's that graded back slope. And they tie, see how this contour runs over here and ties to this one? This contour ties to that one. So I'd shrink wrapped a boundary around the ends of those drawn contours. So I knew that was the extent to which I'm going to work. That boundary now then said, with the exception of where I'm going to, in my new file, this is now going to be a curb and this is all going to be paved. Excuse me, and I'm going to come up to this blue outline for my building. So I knew that this area in here was now going to be that the topsoil stripped area of my existing. So now I'll go back to take this out for a second. I'll just unload it. And excuse me, that's what created this edge over here is my topsoil stripping. I need to turn that back on. There it is. So, you know, those are some of those little techniques. Let me freeze these break lines for a minute. So, so you can see those final grade contours come down, they touch down here, and they're all around that outside boundary is where our work ends. So of all of the existing ground, we only strip topsoil where we're going to be doing our grading work. And this other stuff we'll leave alone. Now we identified that because we had to come up with an amount where if we look at that surface, for instance, let's look at, first of all, the original ground, which is just the tops. And then the, let's see, the base, so original. All right, so here's where you can see there's the topsoil stripped area taken out of that original ground. When it goes back, then the Z I'm sorry, it's the same one. The so here now is that base, or I'm sorry, the final, the design grade with all the subgrades subtracted out. And see, these are the areas in here where we're going to have topsoil replacement, but we come down to a depth. You know, where you can see there's a retaining wall along there, and then these curbs are dropped. And then finally, the net results of that with the subgrades filled in after the topsoils haven't been accounted, but it's still got the drop downs for those designed areas. Okay, now where that comes about, how these little drop down areas are defined are going to be in our definition In this case, we is it not? Should be reading that. Try load and working. Storage is 2. I'm not sure which one's the correct one. It was number 2. Not that one. So that's boundary FG. We'll do one here in a minute. Instead of this, oh, I'm in the existing file. Let me load up the grading plan. All right, so there's my grading plan. There's its boundary. There's my topsoil replacement. All those areas outside where there will be grass, we've stripped in those areas. We're now replacing topsoil in different depth. And so where we get those depths to come into play is now grading plan. I don't know that it was. There we go. Here's design. All right. Yeah, finally. Sorry. All right. So let me back up here a minute. I loaded up a file called Guardian Storage 2. All right. So that had all of this information. Here's my retaining wall. I've got top of wall, bottom of wall. I've got all of these little spot elevations for around my building footprint, my parking lot. I've got top of wall, bottom of wall over here. And so all of that stuff had been elevated. Again, this all came from a PDF. And so that's all now been elevated up like this, including those, you see the wall over there. There's that retaining wall. There's one over here as well. So you see it follows along the ground up here. There's a little bit of height to it. But then on this backside, it drops down to the ground down here. So all of that stuff was done. Now notice I've got some areas. I've got this area, this little tan looking things. Those are those planter boxes. I've got these 2 blue building outlines. And you can see they're at a slightly different elevation because this one was 2 stories. This is only 1 story in the back. And then I've got over here this concrete loading pad. I've got the stairs up this loading dock as well. So this line down here, this blue line, that's my floor elevation, but this green line, that's where the building, that's where the parking lot hits it. So it's, you know, it's down under the ground, but it comes up out of the ground to these other defined edges. Okay, same thing along this edge here and along the back here. So that is done by this setting right in here. Now notice over here, there's some numbers. So I've got my boundary future grade. That was the outside edges. But I don't need those depths. I'm going to go over and turn off my other for a minute. There we go. So now That's just an outline for me. This break line 3D, those were those break lines that I put down some of these contour edges. Or also the wall, the 3D wall. Those are just on a break line layer. There's no depth information over here, but I've got proposed concrete. I've got the truck dock. Then here are my contours where I needed to read back here. There's my curbs, proposed curbs. Again, I just took the edges of them. I didn't give the curbs any particular depth because I gave the proposed concrete some depth. I'll show you that in a second. Edge of pavement, an overlay portion up here in the entrance, and the proposed edge of pavement. Now that's all around this paved area. Okay, and it's a closed polyline. I've got my sidewalk, that's that little magenta colored up here. So it's going to be concrete. And then these other things, there's my proposed wall, but no depths. It's just using the break lines. Some spot elevations around the inlets. Again, just reading elevations. But my building, my proposed concrete, which proposed concrete is at these little entrance doors down there, little concrete pads. My truck dock, which is back here. And then my edge of pavement out here in the street, my overlay, and my proposed edge of pavement. Now, I've taken this and made it a closed polyline all along that inside face, all around here out to the edge, and then closed it. But inside of here, I have other things. So it doesn't just make a surface from edge all the way across to the edge. What happens is just like when you hatch part of your drawing, is it looks inside and it sees these other things and it stops because these then take over. And then when it gets out of those areas, it takes back over to that original thing. So it's the same rule as hatching. Any kind of closed boundaries inside take their own, they do their own thing that we're going to talk about here in just a second. And they are stuck in, they're cookie cuttered into this as their proposed paving, which would otherwise normally just go edge to edge across there without interruption. But now it goes edge to this edge, which is what we want to have happen with that. So we got these series of items on these layers. Here's our proposed building at the closed polyline. This other floor is a proposed polyline, or is a closed polyline. The back wall edges are offset just a little bit so that we can't have a vertical edge. It's just going to be offset a bit. But if we double click that or select it and choose the edit layer button, it's going to bring up something like this. Now, are you guys using this when you're doing your work now?
Yes, I am.
Okay.
I've not been, but now I will be. This is sweet.
Yeah. So this is where you can give it a name. Here's my building slab. It's already in design, but I can change it from here if I want. I can give it a color. And when I do that, I've got a 3D drive view command that I can see what everything looks like. And I tell it the type of material. It's either going to be by area, or it's going to be linear, or it's going to be like a back of a curb, which would actually take into account a curb template. You can give it a material cost per either square feet or count or length. So if it's, something like number of fire hydrants or whatever, you just want to count. We didn't put any costs into this thing yet. We're just looking at volumes. And then we're saying, all right, I want you to adjust the target by this depth. So I've got a 4-inch concrete slab. I've got 6 inches of 2A stone. And again, if you had costs based on, even though, it's going to compute, it knows the area, but you could say, do it by volume, and you'd give it a cost. Or if you knew the volume of something, maybe if you're doing a weight factor, if you're doing it by tons, then you need to fill out the, pounds per cubic foot densities. So anyway, we assigned those materials. So right now I've just assigned a 4-inch thick concrete slab, and then under that, a 6-inch layer of stone. All right. And then over here on our proposed concrete, these are little concrete pads. I've got AA concrete, 6 inches concrete, this is like under the sidewalk, and then a 6-inch stone base under that. It's a heck of a sidewalk.
I do have a question. You made me think of it. So I use this, but some engineering firms we work with, they require a compaction factor, and I've never done that in Carlson.
Okay.
I just thought about it. We don't have to do it now, but I just want to make sure that I brought that up.
Yep. Yeah. So let's look at this EOP proposed. That's our paved areas, 13 inches thick. And down in here, we've got our wearing course, 1.5 inches of asphalt. Here's my shrinkage factor. Okay, so there, if you have shrink and swells would be negative shrinking factors. Okay, or not. Say if you had a swell factor of 1.15, the shrink value would be 0.85 instead of 1.15.
Mm-hmm.
Or you could put negative 1.15. All right, so again, so here's my wearing course. Here's my base course. Base course of asphalt of 4 inches, and then I've got a sub base under there, 8 inches of stone. So my asphalt, top coat, bottom coat, and stone. And so that defines 12, 13.5 inches. And that's that 13.5 right there. And here's my sidewalk, for instance, my 8 inches. I've got a 4-inch concrete, a 2/8 stone. That other one that I did, sorry, what was I? Proposed concrete. These were my concrete pads, not the sidewalk. Okay, so once you've done that and you build those surfaces, let's take a look at, do a quick profile from surfaces up. I built my design. Let's do my existing file. And let's take the, see, OGZE. There we go. So I built my existing separately in a different drawing, but I can point it to that. I'll now make existing, make design. I don't think I need to. Let me look at my checklist. Yeah, it needs to be updated. Existing, I did update it just now. All right, so now my quick profile from surfaces. If I look at this, say from, let's go across one of those planter islands. And now if I want to look at my subgrade adjustment, and it didn't make the design yet. Got some. All right, now. There we go. That's what I want to talk about. All right, so let's zoom this up a little bit here. And you can see when I walk down here, you see where I'm tracking on the profile view. You can see it in the plan view where I actually am. So what I've got with this, and if I do a one-to-one, you see it's not quite as severe looking as all that. This is more of it on a true scale. Before I had it set to fit. So as I track this, see the different things I can show over here. I've got the original ground, topsoil removal, design surface, subgrade adjustment, and then the final target. Those are, and some of those are just superimposed exactly on top of the others. Like if I uncheck subgrade adjustment, go back to final target. And then if I turn that subgrade adjustment on, those would stay put so you could see it. Design surface. So right up here, for instance, see where I'm tracking in the profile view below. See, I'm in that little planter box. So that's the adjustment of that, but the top yellow line is the final surface. Of course, the white line down below, that's my original ground. And you can see down here, the same thing at the bottom of my building. You can see the bottom white line down there. That's the one that's tracking. That's the excavated, the subgrade adjustment, whereas the yellow line is the finished surface. And if I take this, let's go, let's move it up to here. Adjust alignment, I'll put near the end and come back out. This other, let's come up to here. So now, here I can come, you can't really see. There you can see that little bit around the curb. You can see where I'm tracking the bottom. See that white line in the profile? That's my extra excavation for my pavement. The yellow line is the final pavement. Then it steps up over the curb island and then back down into these building areas. Put this on a fit. All right, so now watch what happens right in here as I'm tracking. I'm on the building down here, and then when I get to this next level, I'm going to step up. And now I'm into that second floor. And see, it's going to come out. It's going to be under the ground all the way down to here, and then it's going to come out up to right there and step out into the paved area. So that paved area comes all the way across, so it hits the building, and it knows that it's making that transition.
Okay. So when you get all these different layers in of, your subgrade or your topsoil or your flower beds, when you go to say put those on the machine, are those all separate files, or how do you actually?
Yes, well, that's what those files were here when we set this thing up. These suffixes.
Mm-hmm.
So the design surface before any adjustment is just a base design.
Okay.
Once you've taken into effect the zones, those subgrade zones, it is a .z or -zn. But if you then want to accommodate for the topsoil replacement on top of this, then that adds this part. That's the final top of the surface that you're going to grade to, which includes the topsoil replacement. This one does not. This is my subgrade zones, but then it jumps up to the actual.
So your before adjustment is like your finish grade. After the subgrade zones is basically holes in it for your aggregate base or whatever it is.
That's the ZNs that takes care of the subgrade zones.
Okay.
Let me see if this will help. Might explain something quick. Yeah, here it is. The default name of the original ground before any adjustments. That the ZE is the name of the original ground after you've made any subgrade zone adjustments to the original ground. And then the next EX is the original ground after the subgrade zones and topsoil adjustments have been provided, if you provide those, okay? So you don't necessarily have to. And so same thing for the finished ground now, these three. The before adjustments, then this one's the end is after you've made subgrade zones adjustments, and then they, well, that says SG, but I think they called it by default FN. That's the design surface after the subgrades and topsoil adjustments had been made. I guess they called it SG. You're thinking subgrade, but and it can be anything you want, but it's FN. And then any over excavation surfaces we could have in here as well. So it would take those, and also after you've accommodated for the subgrade and any topsoil adjustments, but then have to over excavate under, you know, a pipe trench or whatever, or maybe some bad soil, you got to over excavate to a pocket or remove some rock or something like that. Okay. So if you want to then take this out to your dozer without having to do that dial down, you would take you would take the file, the one that you would use is the one called the ZN or the FN if you wanted to account for the topsoil. I wouldn't, I mean, how do you prepare a site? You get it all into place before you put your topsoil on top of it, right?
Mm.
Yeah, so I would take this ZN, which doesn't have the topsoil in it, and that would be what I would grade to. And now to get that onto my machine, I would go to my surface menu and I would come down here and I would export, let's say in your case, to a Trimble file. And it says, okay, pick the file you want to export. So I would come down here and find that .zn file and say, open. Now it's going to convert to a TTM file. I have no way of reading it on here to show you, but that would be the file you put on a thumb drive and stick out there on your dozer controller, and off you go. Okay.
Right. So you're just picking whatever extension of the file, whether it's FN or OG or whatever it is.
Correct.
Got it.
And that's if we let Takeoff build those surfaces, which is what we use the product to do. Otherwise, you certainly can make your own surface based on collecting all of these elevated lines and such. And you would just do that from our triangulate and contour. And on the triangulate tab, you would give it a name and you could call it anything you wanted. But that's, see, there's a little bit more work involved in that if you've not cleaned up and everything based on layers and based on these close polylines having depths and material depths, which also allows you to, you know, do these material quantities, for instance. Report cost, time, strength. I think just take the defaults. Let's see what it does here. So it's going to reach. All right. And I've got some. It's got a couple of areas that aren't closed polylines, but anyway, what what that does do is give us you can't really see that very well. Let's see if I've got something here. My volumes report, just a single page. What else did we have? These material quantities. There we go. So see, that was based on those stones, my binder course or base course, my wearing course. There's my concrete. Here's my concrete slabs. This concrete was defined for the sidewalks. There's for my slab. That was another thing that I had separated. I don't remember what it was. And then down here's the material and explaining what it is. Concrete 2A is my standard 6-inch. Concrete standard 4-inch. My concrete slab was my slab on grade 4-inch with 6-inch 2A stone sub base. So, you know, it built all that for me to be able to, you know, put into reports or spreadsheets or what have you. Okay. Same thing. Those other reports. There we go. If I look at this one, for instance, now, there's the overall drawing, and you can see, you know, the building and the parking and all the grading, such. Well, that was the original ground, the final grading superimposed, and then the volumes involved, the materials, again, topsoil removal, replacement, amount of cut and fill, and the depth zones. It actually tells us that I've go from 0 to, I've got this many cubic yards here. Well, it keeps it like in 0 to 10 inches, 10 to 20, I've got this. So, you know, that tells me by zones, if it's helpful. There's all kinds of options you can put on those reports.
So can you customize those zones to whatever depths you
Oh
want?
yeah, absolutely. And yeah, 0 to 10, 10 to 20, you can make those whatever you want them to be. Or you don't even have to see it. I'm trying to get, there's a better one. Let me see if I've got. No, I don't have it on my desktop anymore. Better project. Let me see here. In the earthworks report, this is balanced. Yeah. Normally, when I put these things together for a client, I think we just looked at that one, didn't we? And then I'll have so there's all my yeah, there we go. This is the type of report that I'll put together for the client. So it tells me, you know, my overall 26,000 yards to take away kind of stuff. Material quantities, what they're supposed to be. Topsoil, amount of cut and fill. And then here are my areas that show my replacement zones. Topsoil stripping across the entire disturbed area. So it's stripped there, and then replacement. This is where I'm going to replace. I'm not going to put topsoil in these areas, only out in here. And then here's how these things look. The final surface, the top surface without subgrades. There it is with the subgrades shown and applied by color, and then merged into the existing. And then finally, a composite by color subgrades into, or final rather, but by color merged into the existing. So those are the kind of things that you can generate out of all of those, all of that work. Same thing, materials. Here's the existing grade. And that's what it looks like when it's done. All right. So that puts us up here. We're running a little long for our break. So let's take about, we'll come back about 10 after 4 and we'll wrap up till, we'll target to try to get done here by 4:30. And then we're going to get into some actual rolling up your sleeves, getting your hands dirty kind of work for tomorrow. But that's the basic process, is that you define those areas. You have those closed off areas, closed polylines, so that when you define the material depths, it knows where to apply that. And again, like I said, if you've got this outside closed polyline and then there's something inside that is a separate area, then it only goes up to those edges and stops. It doesn't go all the way across. And it's that concept of building that from the top down to those defined depths is what generates those zones, and then it will accumulate all of those materials for you. Okay. We'd also want to take a look tomorrow as well at a little bit of some of the road design tools, since if you guys are doing that. Now we're not going to get heavy into road design theory, because again, you're going to get the design from somebody else. You just got to build the structure. So
Correct.
I think it would be useful tomorrow if we spent some time taking, say, cross sections or typical sections and making surfaces from those.
All right. So
if you have anything like that.
Sure. So surfaces from cross section data. If you've got an example of some drawing files or PDFs or anything like that that you want to look at with that, just email me that, so I can look at that. I don't really have a lot of things as sample data to show you with that. So if you've got one that you want to look at, why don't you send me that file and we'll work with that one. Send it to both of us, so we can, then load that up tomorrow and take a look. Let me think of, well, I'll take a look at it here over break. There's no need to hold you on, but let's come back about 10 after, and then we'll wrap up and get into some of these other things. And also, and Drew, for you as well, any of you guys, if there's any particular topic you want to take a look at, let me know, because we're small enough, we're not going to have to stick to a prepared script. We don't have 8 other people to try to accommodate, so we'll take a look at those things as well. Okay.
Okay. Yeah, I got a couple. We can talk after this.
Okie dokie. Well, with that, I will turn this off. I will pause our recording again and see you back at 10. We'll resume the recording. And there, so hope everybody got everything there. I'm about a minute or so past. I apologize. I got stuck on a phone call with a client. When, let's see, I saw in the email, Drew, that you had sent about your cross section. So I'll take a look at those tonight and see what we need to talk about tomorrow. And as far as trenching goes, we don't have trenching as a separate tool in the IntelliCAD construction module version. You need to, you would have to have the, I think, let me see. Yeah, you need to actually get to the trenching module, which has these tools in it that you would get. That's also in, but they are incorporated here in the R11, 12, 9, whatever. There's this whole trenching segment. So you basically have the trenching module incorporated into your standalone as well. And it's potentially pretty neat. It'll give you some good little computations in your network. Okay, so let's see. There we go. Let me put that back down. So there we go. All right. So we'll take a look at some of that stuff tomorrow as well. So let's get into a typical workflow with a file that's mostly converted and see some of the tools that we would normally use. So I'm going to go ahead and close this off. And I'm going to open. And again, I'll get into this 3D machine control class in my, I don't think I want to get into that yet. Now we'll get into the getting started. Is there anything? Take a look at something here real quick before you load this up. I want to take a look at that. No, nothing I want to talk about today. All right, so let's open in our getting started folder this demo 1. Let's see what else I've got in here. Since it's in use, let me see. Oh, no, I know what that's from. Never mind. All right, so we want demo 1, but let me take a look at this one just a second. All right, so that one has been fully elevated. Oops, if I open demo 1. Yeah, okay, so this is That's what I want. All right, so go ahead and open demo 1. And let's take a look at what we've got. When we look at this in plan view, it looks like a typical grading plan. In fact, this is out in California. I don't know if I knew the state plane zone, we could load up the Google image, the Google Earth image, and see what it looks like out there on the ground. So this is a real project. It was actually built. Now, what we have here is this polyline that's drawn all around the final grade. Now notice it's drawn all the way up to the back of the curb, all the way around it here. All right, so they're saying, all right, that's the end of my design. That's going to be where I'm going to calculate my volumes and go from there. But really, what happens in reality is you're going to build this parking lot out to this edge. But what happens in here? You're not going to just, I don't know, what the difference is. We're looking at, 16 or 1730 for that top of curb up to 1930. So about 18 feet of elevation in there. And this polyline is at from 22 to 20. So that's at 22. This edge is at 19, or let's see, 17 to 19, about 18. So that would be a 4-foot drop off right in there. Now you're not going to have unless you're building a retaining wall. So normally you would build up here and then you would taper off, you would go out there and target the existing ground at some kind of a slope. So that's what I was saying about these boundaries. What I like to do is when I establish this back edge, I'm going to also use a tool that's going to go out here and find the ground at a given, maybe I've got a 2-to-1 or 3-to-1 slope. So I'm going to go out and find the original ground. And that's actually the boundary of where I'm going to be working. All right, so there's one difference that we're going to be looking at. There's a couple of other things in here as well. We've got these drawn contours that we're going to use to build our existing ground. But if I look at this right here where this break is, let's go ahead and get some more of these as well. You're going to notice something when I spin this thing up. Notice there's an obvious visual or vertical discontinuity right there between those two slopes. Okay, that's because this data came from maybe from 2 different sources. Who knows what they are. And so that's 20, 15, 10. So a 5-foot contour interval here, and it's a 1-foot contour interval down here. But as long as they're at the right elevations, that should be 10. It is. That should be 15. It is. This one should be 20. It is. 15. It is. 10. It is. Okay, now. So there's some issues that would normally, we would want to have them resolved before we get into trying to build that too much. But sometimes all you have is what you got, and you got to move ahead. So, there's also some differences out in this corner, if I recall. Something goofy down there. I see. It's because that is at some kind of weird elevation. But you notice right in there, there's also that visual or that vertical discontinuity between those two slope edges. So, we would either resolve those or just live with the differences. And I noticed that this was at an elevation of -0.230. So one of the first things I'm going to do is run drawing cleanup. And I'm going to clear everything, and I'm only going to do a couple of these. I'm going to, let's remove any duplicate text, any points, overlap loops. We'll join line work with the same endpoint, so that'll stitch our contours together. And then erase any blank text. I don't think there's any. We'll remove these little segments of, say, less than 100th. And we're going to set, once I scan, you see I've got this -4230. I know my site's up around 800, so I'm going to say from 500 to 1,000. And then I'll say, okay, enough, it's going to go. So it joined up a lot of the lines for me. There were no blank text, no overlaps, but it removed 3 fragments, less than 100th, no duplicate text, and there were 22 entities outside of that elevation range it's set to 0. Those are those labels. So now when I select everything, those labels won't show up down there as -0. They're all on the bounds. And so now I see the only thing that actually does have elevation are my contours. Okay. And right now we'll just live with those as they are and not worry about these little discontinuities. But knowing that that's something that we typically would either resolve or ask whoever gave us this information to resolve it for us. But that's going to be the basis of what we do our design on. And I think they're all on the same layer. I'm going to find that out by going to view, isolate layers. I'm just going to pick one of those and make sure they all stay there. That look like they did. I'll now restore the layers and make sure. Yeah, the only thing that came back in was this other, the building and the parking lot. All right, so that's going to be good for our existing. We'll do that. We have this boundary out here that they use for their boundary. If you do that, that's going to calculate materials and do everything just within that area, or we could go out to wherever these tie slips are going to be. And we'll do that, you know, some maybe as a refinement step. For right now, we'll leave it at that. So let's step through our defining the layer. So I'm going to choose that define layer, surface. And if I'm looking at others, I've got my index contour, index depression, oops, index what's going on there? Index contour, depression. Let's get my labels. It won't matter if that text, I just want to get these index and intermediate contours on here, and I'll move those to existing. I'll move to, and I'll save that and exit. Now, the reason I did that was to verify that I got everything. And over here on my display tab, also on the takeoff menu, where I can, here's where I can set things by picking them. There's my defining, that's where I had that dialogue. But now I can come down here to my display portions where let's see where they put it.
The layer stuff's in view now if you're looking for that.
Say that again.
I believe what you're looking for is in view, but
If it is, this is different from the other modules. Let me see if, let's see, these are all different. This is just for the drawing in general.
right.
Um, It's this display existing. These are the things that I want to do, but they should be on this menu also. That's what I'm looking at. Uh, huh. Here's my make. Here's my sets. So there should be some display commands in there. I don't see them. Let's find it real quick. Let me look at these display options. It's a keyboard command, but no. Oh, there should be, I see, there's a display menu.
Yep, that's to the right.
Oh, sorry, there it is. I'm sorry. I thought you were saying view menu, but it's display. Yeah, there it is. So you can display these different things with the options, and here's the toolbar for it. But anyway, I'm going to, now that I've set existing, everything else is other by default. So if I'm going to click that button to turn everything else off, and if I turn my existing off, that's all gone away. I'll turn other on, and you can see everything else. And there's a couple of that's area labels: asphalt, asphalt, some elevations. Those are those contour labels out there, which were just added after the fact. They're not going to bother us there. So I'll turn other off, existing back on. And again, it was all already at elevation. We saw that by the fact that there's no red. I've got that marked. I can also spin that up in 3D in real time by holding the shift key and holding the mouse wheel and moving that around, and then type plan at the command line to come back to plan view. All right, so I'm in good shape to build that existing once I've defined the boundary. I haven't defined the boundary yet. So I'll set my boundary polyline. And it says it already has one already set. So whoever put the data set together already set it. I'm going to go ahead and clear it and then reselect it. So now I've got my boundary. I've defined the layer. I look at my checklist again. I've set my boundary. I've defined it says it's missing, but I haven't, because I haven't told it design yet. I've got existing. I don't have design yet. I could take, if I knew what these were and do it, or I could, an easier way is to choose the set layer for design, which lets me pick it. I'm going to pick the building, the parking edges. I'll go ahead and get these text in case they're on a different layer. I just want to see them. I'm going to get this little landscape island, and that should be it. I'll say enter. And now they're all red because they're at 0 elevation. We'll come back to that. So now if I turn my existing off, my design off, this is what's left as my other. And I turn design back on, and I see these in here are just 818, 819. Those don't make any sense. I have an 1870 for my pad. this is on a layer called texts. I'm just going to freeze that layer. I think somebody put that into this file from some other. Turn this back on. Yeah, those are labels they added after the fact to these contours. And they have other labels in other places, probably, like on this. All right, so what I'm going to do is I'm going to put all those on the same layer as one of these. And I'm going to do that using a selection trick. I'm going to select using a filter, FIL, down its command line. Command line I want to do, I'm going to filter by layer. So I'm going to include, I'm going to set text, I think it was plural. Everything else is off. And by type, I'm going to say include text. There it is, text. All right, so I'm going to say select all those. And I've got 12 entities in my selection set. I'm still selecting. I hit enter to finish. I take a look at all those little grips, and that takes care of those items. All right, so that's now built into that selection set. I'm now going to come over here and change that to my index label layer. And they're now done. So I select that and it's on that. No, what happened? Select. Oh, it's not reading over here in my selection set. All right. So that's there for that. Now let me see if I can apply this. If I do this. Change its layer. Okay, it's fine. Now select the entities. If I type P for previous, nope, it won't let me do it that way either. So if I select based on a filter that's selected. And now if I change property, select the entities to change, I just type P for previous. It's now selecting all of those. And now what I want to change is my layer. And I'm going to put that on index label. Of course, I forgot what it is. Let's see if I manage to get that on the index label. Yeah. Right. So now I turn my design off, or my existing off, turn my design off. They only, we got two things out here. One little thing right there, just that piece of a line. Let's see where that is. It has nothing to do with anything. I'm going to just delete it. And I'll also put these. I can live on other, that's fine. All right, so design on, so existing on, design on, other on as well. All right, so we've got a boundary, we've told it this, we've told it
that we can make our existing ground. When we do that, it's going to, we made it. I can view that as my demo one EX. Now these are all the same thing, my original ground and my zone exclusions, everything is done there. That should correspond to those, or closely to those same. Now notice it didn't build those slopes out here because our boundary cut it off. Right, so that may be another reason why they didn't fix that part out there. So that part's ready to roll when we come back to this tomorrow. We are actually past our time a little bit, so I won't hold you over. But we'll go through a couple of things here on how to elevate these items, and we'll go from that. So what's going to happen is this outline of our outside of our parking lot will behave according to that pavement, and then it's going to also hit this edge and this edge and this edge and this edge, which all have, you know, this little pad's going to have a different depth. This little landscape island is going to have a different depth of material. Same thing as this one up here, in the middle here. But our parking lot's going to go from that closed boundary to all of these closed boundaries and stop. It'll hit this other closed boundary and stop. So all of this will be our parking lot. And then we've got this parking lot edge here, and it's going to go out to the building, and it's going to just basically slope that off in between. Now, we normally would have potentially, you know, some elevations or other kind of information in there if there's any kind of grading work. Same thing in here. It's going to go from this edge over to this edge, and you see that's at 1756. This is 1870, so it's a foot lower. So it's going to slope it down just linearly between those edges, unless we decide that this building is not only at that elevation, but maybe there's a pad sort of all the way around it, and it even closes off across here to that. In that case, you know, you got this one at a different elevation, this one at a different elevation. And so it linearly interpolates there, but it would also, if we put that front edge on it, do the same thing in here. So it would, works like the hatch command, basically does everything inside of here, does everything inside of here. This parking lot would normally do everything inside of the parking lot, but it's going to hit these other boundaries and stop. Okay, so that's actually this parking lot will look at this parking, this parking, and it's between those two that the asphalt definition gets applied. Goes from that asphalt definition, it finds a building definition. So this stuff in between, it builds it as a surface, but it's just going to be ground. It's going to be graded area with no definition because there's nothing that defines anything in there. If we wanted to create that as its own separate thing with a different depth, we need to also include this line and this line and called that something like landscape, so it knows how to behave in between. Okay, so looks like Josh had to scoop, and like I said, we're out of time, so we will put a bookmark here. Go ahead and save your file. When we come back tomorrow, we'll finish this part up and see some of the tools to elevate these things with, and so a typical workflow and how it takes care of those subgrade areas and then also look at maybe tying this back slope down into our existing ground for a more complete design on that part. Okay?
Sounds good. Thank you.
Questions, anything like that, or we can pick up tomorrow if you're good.
Nope, that sounds good to me.
All right, sounds like a plan. I'll see you guys tomorrow morning. I'll send you, I'll send everybody the links for the day 2 session.
Okay.
As an email later tonight, and then again in the morning before we start. Okay.
Okay, that sounds great.
All right, sir. Thank you very much.
Thank you. Have a good night.
Take care now.